Assalamualaikum, selamat pagi.
May I have your attention, please? As the opening ceremony will commence shortly, please kindly take a nice seat and be sure to check on your name under a given format as follows. Please use room name _ presenter name _ paper ID for presenters and use institution name _ name for participants. We would like to remind you to put your microphone in muted mode. And before we start the opening ceremony of the first International Science and Technology, let us watch the information video about Universitas Terbuka.
Dengan tuntutan era digital yang semakin pesat, memacu kita untuk terus meningkatkan potensi sumber daya manusia yang terintegrasi dan mampu menunjang produktivitas. Namun, perkembangan yang kian padat tersebut perlu diimbangi dengan solusi pembelajaran yang efektif dan modern yang mampu mengimbangi rutinitas masyarakat masa kini. Sebuah sarana yang mampu mengatasi keterbatasan tempat dan waktu yang menjadi masalah utama bagi banyak orang dalam mengembangkan diri dan peningkatan karir di era digital yang berdampak pada gaya hidup. Universitas Terbuka hadir untuk menjawab masalah tersebut dengan penerapan sistem pembelajaran terbuka dan jarak jauh. Sistem yang terbukti efektif meningkatkan daya jangkau dan pemerataan pendidikan tinggi yang berkualitas bagi seluruh lapisan masyarakat. Sistem pembelajaran Universitas Terbuka memungkinkan para mahasiswa untuk belajar secara fleksibel dan terbuka dengan beberapa keuntungan seperti waktu pendaftaran yang terbuka sepanjang tahun sehingga Anda tidak perlu khawatir untuk terlambat melakukan pendaftaran, ruang, waktu, dan tempat yang fleksibel bagi mahasiswa. Hal ini sangat berguna bagi para mahasiswa yang tetap ingin mengembangkan wawasannya dimanapun dan kapanpun. Materi ajar cetak maupun digital yang mudah diakses di seluruh pelosok Indonesia dan mancanegara. Memberi kesempatan kepada segala golongan dan usia yang siap belajar untuk mengembangkan ilmu dan kemampuannya di segala bidang. Memiliki 39 kantor regional di seluruh Indonesia dan pusat layanan luar negeri yang selalu siap mendukung kegiatan operasional dan jalinan kerjasama dengan berbagai institusi baik nasional dan internasional. Serta dilengkapi dengan berbagai fasilitas penunjang proses pembelajaran seperti UT Radio, UT TV, layanan bantuan belajar, hingga perpustakaan yang dapat diakses secara online. Memiliki 4 fakultas, Fakultas Keguruan dan Ilmu Pendidikan, Fakultas Hukum Ilmu Sosial dan Ilmu Politik, Fakultas Ekonomi, Fakultas Sience dan Teknologi, dengan lebih dari 35 program studi sarjana dan program pasca sarjana. Universitas Terbuka, making higher education open to all.
Selamat datang di Universitas Terbuka. Kali ini aku akan mengajak kamu untuk virtual campus tour di Universitas Terbuka. Universitas Terbuka atau UT memiliki kantor pusat di Pondok Cabe, Tangerang Selatan, serta 39 unit program belajar jarak jauh atau UPBJJ yang tersebar di seluruh Indonesia. Dalam rangka mendukung layanan kepada mahasiswa, berbagai sarana dan prasarana dibangun dan terus ditingkatkan kualitasnya. Ayo kita mulai. Di kantor pusat, terdapat gedung fakultas yang merupakan jantung dari pengembangan produk akademik UT. Gedung fakultas telah dilengkapi dengan sarana dan prasarana untuk mendukung kenyamanan bekerja. Terdapat 4 fakultas di Universitas Terbuka dan 1 sekolah pasca sarjana. Fakultas Keguruan dan Ilmu Pendidikan, Fakultas Sience dan Teknologi, Fakultas Hukum, Ilmu Sosial dan Ilmu Politik, dan Fakultas Ekonomi, serta sekolah pasca sarjana. Gedung fakultas memiliki sarana dan prasarana yang terstandar yang terdiri dari masing-masing fakultas menempati 2 lantai. 1 lantai diperuntukkan untuk ruang layanan mahasiswa, ruang konsultasi mahasiswa, ruang dekan, ruang wakil dekan, ruang kepala bagian tata usaha, ruang tenaga kependidikan, dan ruang sidang. Ruang sidang dilengkapi dengan fasilitas video conference yang digunakan untuk rapat koordinasi dengan dosen yang tersebar di UPBJJ, serta ujian sidang untuk mahasiswa pasca sarjana. Ruang dosen menempati 1 lantai yang terdiri dari ruang sidang, ruang dosen, ruang ketua jurusan, dan ruang ketua program studi. Masing-masing lantai dilengkapi dengan ruang makan, musola, dan toilet yang nyaman dan bersih. Masing-masing dosen dan tenaga kependidikan memiliki kubikel sebagai ruang kerja. Kubikel ini berukuran 2 x 1,5 meter. Setiap kubikel dilengkapi dengan komputer yang telah terinstal Microsoft 365 yang berlisensi. Untuk mendukung layanan kepada mahasiswa, Universitas Terbuka juga memiliki beberapa sarana dan prasarana pendukung sebagai berikut. Pusat Produksi Multimedia merupakan unit pelaksana teknis yang bertugas untuk memproduksi bahan ajar. Gedung ini dilengkapi dengan peralatan produksi materi-materi dalam bentuk video dan audio. Produksi materi cetak juga diproduksi di sini dengan menggunakan peralatan dan software terkini. Pusat Layanan Bahan Ajar merupakan unit pelaksana teknis yang bertugas untuk melakukan distribusi bahan ajar. Gedung ini dilengkapi sarana dan prasarana untuk menyimpan dan pengemasan bahan ajar dan bahan ujian. Pusat Layanan Pustaka atau Puslata. UPT Puslata melayani penyediaan bahan-bahan pustaka bagi mahasiswa dan dosen. Puslata mengelola penyediaan bahan-bahan pustaka baik dalam bentuk hard copy maupun koleksi digital. Koleksi digital yang dikelola melalui Perpustakaan Digital UT. Perpustakaan Digital UT menyediakan layanan akses bahan ajar melalui ruang baca virtual. Di sini juga dapat diakses berbagai sumber pembelajaran terbuka melalui Suaka UT dan sumber pustaka online lainnya seperti jurnal dan e-book. Pusat Pengujian merupakan UPT yang memiliki tugas untuk melakukan pengelolaan bahan ujian dan hasil ujian. Gedung Pusat Pengujian dilengkapi dengan sarana dan prasarana untuk melakukan pengelolaan bahan ujian. Bank Soal UT mengelola koleksi soal-soal yang digunakan untuk ujian akhir semester. Penyiapan master naskah ujian dilakukan di Bank Soal. Selanjutnya, penggandaan naskah ujian dilakukan di pusat percetakan dan kemudian didistribusikan ke seluruh Indonesia. Pusat Pengujian juga mengordinasi pelaksanaan ujian online serta pemeriksaan hasil ujian secara online. Universitas Terbuka Convention Center merupakan fasilitas yang digunakan untuk menampung pertemuan dalam jumlah besar dan pelaksanaan wisuda mahasiswa. UTCC dilengkapi fasilitas video conference yang digunakan untuk rapat koordinasi dengan UPBJJ di seluruh Indonesia. Di samping UTCC, UT juga memiliki fasilitas wisma yang digunakan sebagai akomodasi untuk kegiatan yang mengundang pihak-pihak dari luar UT, misalnya dalam rangka pengembangan bahan ajar, pengembangan bahan tutorial, dan pengembangan bahan ujian. UPBJJ sebagai ujung tombak layanan kepada mahasiswa dilengkapi dengan berbagai fasilitas berikut. 1. Ruang pelayanan mahasiswa. 2. Ruang sumber belajar yang dimanfaatkan oleh mahasiswa untuk mengakses berbagai sumber pembelajaran online. 3. ruang kepala UPBJJ. 4. Ruang kerja dosen dan ruang kerja tenaga kependidikan. 5. Ruang sidang yang dilengkapi dengan fasilitas video conference yang digunakan untuk rapat koordinasi dan pelaksanaan ujian sidang. 6. Ruang tutorial yang disediakan untuk memfasilitasi tutorial tatap muka yang dilaksanakan di UPBJJ. Dan 7. Ruang ujian online. Gimana? Seru kan virtual kampus tour-nya? Terima kasih sudah mengunjungi Universitas Terbuka. Sampai jumpa. Universitas Terbuka, making higher education open to all.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, distinguished ladies and gentlemen. Allow me to extend our greetings to honorable speaker and guests, Professor Insinyur Nizam MSc DIC PhD IPU ASEAN Eng, as Director General of Higher Education of the Ministry of Education, Culture, Research and Technology, Professor Ojat Darojat Mbes PhD as Director of Universitas Terbuka, Professor Shobarangganathan as Professor at Macquarie University, Sydney, Australia, Khalis Abdurrahman Audah PhD as Associate Professor at Swiss German University, Indonesia, Muhammad Ashif Khan PhD as Associate Professor at Perdana University, Malaysia, Professor Dr. Hafizan bin Zuahir as Professor at Sultan Zainal Abidin University, Malaysia, Dr. Wasim Haider as Associate Professor at Central Michigan University, USA, Dr. Ernik Yuliana SPIMT as Associate Professor at Universitas Terbuka Indonesia, Dr. Subekti Nurmawati MSI as Dean of Science and Technology Faculty, Universitas Terbuka, and last but not least to all presenters and participants. Welcome to the first International Seminar of Science and Technology held by Faculty of Science and Technology, Universitas Terbuka. I am Fenty Fitriani Nurunisa. I'm very honored to be the host for today's event. Ladies and gentlemen, first of all, let us be thankful that we can gather for here today, October 14, 2020, because over the next few hours, we will have opportunities to discuss and share knowledge, insight, and of course, current development related to the theme of this International Seminar of Science and Technology for Society Development. This seminar is held by Faculty of Science and Technology of Universitas Terbuka in collaboration with the Indonesian Society for Bioinformatics and Biodiversity, Indonesian Operation Research Association, Swiss German University, Sultan Zainal Abidin University, BTN Bank, and Mandiri Bank. Therefore, we would like to thank and appreciate all the sponsors and partners that have supported this event. We would also like to thank our keynote speakers, plenary lecturers, and all the presenters, and as well as participants for the participations on today's event. This international seminar is a part of the 37th Dies Natalis of Universitas Terbuka, which is held annually on September the 4th. The theme of Universitas Terbuka's Dies Natalis for this year is Developing Human Capital Excellence through Digital Learning Ecosystem. Therefore, to strengthen the theme of our Dies Natalis, Faculty of Science and Technology has raised the theme of Science and Technology for Society 5.0. Excellencies, ladies and gentlemen, allow me as the host to read the agenda for today's event, which will begin with the opening ceremony started by the national anthem of Indonesia and followed by the opening prayer, by Mr. Dedi Ahmad Suhardi, SSEMM. And we will be continued to welcome speech by the Chair of ISST Committee, Dr. Insinyur Isfarudi, MPD, and welcome speech by the Dean of Faculty of Science and Technology, Dr. Subekti Nurmawati, MSI, followed by welcome speech by Director of Universitas Terbuka, Professor Ojat Darojat, MBus PhD, keynote speech from Professor Insinyur Nizam, MSc DIC, PhD IPU ASEAN Ang, as Acting Director General of Higher Education, Research and Technology of the Ministry of Education, Culture, Research and Technology. And we will be continued to the International Seminar of Science and Technology book launching, plenary session, presentation session, and it will end with the closing ceremony. Ladies and gentlemen, without any further ado, as a start to our opening ceremony, we will sing the national anthem of Republic Indonesia. We would like to request you to remain seated during the song. Thank you. Our next agenda is to have the opening prayer. For that, I would like to invite Mr. Dedi Ahmad Suhardi, SSEMM, to lead the prayer.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ladies and gentlemen, let us spare a moment to pray to God Almighty. We would be pleased if you could follow the prayer along. This prayer will be read according to the Islam faith. For non-Muslim, please adjust according to your own faith and beliefs. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala asyrafil anbiya'i wa mursalin. Sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in. Ya Allah, the most gracious, the most merciful. All praise belong to you, Lord of all universe. We give thanks to your our present for all your grace, so that today we can hold the first international seminar of science and technology for society development 2021. Ya Allah, you are the source of all good. Our lives are witnessed by your nature and will. In the beginning, you gave us the eloquence of speech and since then, you lead us to be humans who are caring and beneficial with all your guidance. Bless this activity as part of your grand plan to increase our human role through the use of science and technology for the development and benefit of society. We hope that the activities and each interaction with the seminar will strengthen the relationship and partnership between us all, therefore producing ideas and body of works that are beneficial for the welfare of society and the preservation of nature. Ya Allah, be exalted in might, the wise, through the effort of our predecessors, science, technology, as well as various life skills have been given to us. Grant us purity of soul, determination, and wisdom, so that under the protection of your grace and majesty, there will be no shortage of answers to manage various problems of the current time through science and technology. Forgive us for all our mistakes and bless our predecessor with your grace. Bless us with good deeds and sincereness of worship. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Amin ya rabbal alamin. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Suhardi. Next is welcoming speech by the chair of the first International Seminar of Science and Technology. Before, I would like to thank Professor Ojat Darojat, Khalid Abdurrahman Audah, PhD, Professor Zuhair, and Dr. Anik for joining us this morning. And the next, please welcome Dr. Insinyur Isfarudi, MPD.
Thank you, Ibu Fenty. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. A very good morning, ladies and gentlemen. Honorable Professor Engineer Nizam MSc, DIC, PhD, IPU, Asian rank, Director General of Higher Education, Research and Technology of the Ministry of Education, Culture, Research, Technology, and Higher Education. Honorable Professor Sobaranganathan, Professor at Macquarie University, Sydney, Australia. Honorable Holis Abdurrahim Audah, PhD, Associate Professor at Swiss German University, Indonesia. Honorable Muhammad Asif Khan, PhD, Associate Professor at Perdana University, Malaysia. Honorable Professor Dr. Hafizan bin Zuhair, Professor at University Sultan Zainal Abidin, Malaysia. Honorable Dr. Wasim Haider, Associate Professor at Central Michigan University, USA. Honorable Dr. Agni Yuliana, SPI, MT, Associate Professor at Universitas Terbuka, Indonesia. Honorable Professor Dr. Andes Ojat Darajat Tembas, PhD, Rector of Universitas Terbuka, Indonesia. Honorable Dr. Subakti Nurmawati, MSI, Dean of Faculty of Science and Technology, Universitas Terbuka, Indonesia. And to all seminar presenter and participants. First, as the chairman of the International Seminar on Science and Technology, Faculty of Science and Technology, Universitas Terbuka. I would like to welcome all participants of this seminar. May we always be in good health during COVID-19 pandemic. This year is a special year for us, especially for the Faculty of Science and Technology, because we are able to organize the first international seminar with the theme Science and Technology or Society 5.0. We are very grateful with the all support given by the Rector of Universitas Terbuka and several partners involved in this seminar. On behalf of the committee, I would like to express my deepest gratitude. We have received a total of 70 scientific articles from academics, practitioners, and lecturers from various institutions. The articles are classified into 3 subtopics, namely Big Data Science and Technology Information, Food Security and Health, and Biodiversity for Sustainable Improvement. All articles submitted will be part of the publication of proceeding of the International Seminar on Science and Technology 2021. There are about 600 participants in this seminar. They come from various public and private universities, research institutions, ministries, government agencies, local government agencies, and several private companies. They have position as students, lecturers, researchers, teachers, engineers, and practitioners. Within this seminar, we have also compiled a seminar book that comprises of various ideas and work of our faculty's lecturers regarding the role of science and technology in the era of 5.0 society, about local security and big data, science and information technology, as well as biodiversity for sustainable improvement. This book contains 14 articles that involve 23 writers from inside and 5 from outside of Universitas Terbuka. The book will be launched as the beginning of main activity series of the International Seminar on Science and Technology. Lastly, please enjoy the seminar. We hope that you will have a pleasant experience during the seminar, but in the form of useful scientific knowledge, as well as network experience with various expertise involved. Thank you. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Isfarudi, for the warm welcome. Next, let us continue to hear the welcome speech of the Dean of Faculty of Science and Technology. Please welcome Dr. Subekti Nurmawati, MSc.
Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes to all of us. Honorable Professor Nizam, PhD, Director General of Higher Education, Research and Technology of the Ministry of Education, Culture, Research and Technology, Prof. Soba Ranganathan, Professor at Macquarie University, Sydney, Australia. Holis Abdurrahim Auda, PhD, Associate Professor at Swiss German University, Indonesia. Muhammad Asif Khan, PhD, Associate Professor at Perdana University, Malaysia. Professor Hafizan bin Juahir, Professor at University Sultan Zainal Abidin, Malaysia. Dr. Wasim Haider, Associate Professor at Central Michigan University, USA. Dr. Ernik Yuliana, SPIMT, Associate Professor at Universitas Terbuka, Indonesia. Rector, Vice Rectors, and all leaders of Universitas Terbuka, Indonesia. And a very good morning to all participants. First, praise is to Allah Subhanahu wa Ta'ala, because with His permission, today we are all able to attend the first international seminar on science and technology. This event is organized by the Faculty of Science and Technology, Universitas Terbuka, Indonesia, with the theme Science and Technology for Society 5.0. Allow me to thank all of you for taking the time to participate, both as keynote speakers, invited speakers, presenters, and as participants in this seminar. This is the first international seminar held by us, the Faculty of Science and Technology, and we plan to organize the seminar as a yearly event. The big theme of this year's seminar is Science and Technology for Society 5.0, with three main sub-themes, namely Big Data Science and Information Technology, Food Security and Health, and Biodiversity for Sustainable Environment. The theme was chosen because we realize that the role of science and technology is very important, especially in overcoming every challenge and dynamic change in life. The role of science and technology is like a double-edged sword. On one hand, we can use it to overcome problems such as identifying natural change, analyzing social phenomena in our society, and finding solutions related to the disasters we are currently experiencing together, a global pandemic of COVID-19. However, on the other hand, the application of technology without precaution and proper humanity policy can also lead to disaster. Dear honorable guests, keynote speakers, presenters, and all participants, roles of science and technology have evolved. Now we are entering the Society 5.0 era. Therefore, it is important to take advantage of technological advancement to improve the quality of human life without damaging the environment and social structures. Optimization of many novel discoveries and application in science and technology usually involves data collection, processing, analysis, interpretation, and data presentation. Of course, the use of any technological advancement must be carried out in all fields of knowledge and synergy. From food technology, agribusiness, biology, urban and regional planning, mathematics, statistics, information systems, etc. Therefore, technology utilization involving a multidisciplinary approach will provide different perspectives to tackle many essential human or society problems globally. And we hope that this seminar will provide a pleasant experience to all of you for discussing such phenomena. Lastly, I would like to thank you for all the support from various parties so that this seminar can run well from the first day of preparation until today. And to everyone, We hope you have a great time in today's seminar, and we look forward to a very exciting scientific discussion today. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Nurmawati, for a very spiritful speech. Lastly, let us continue to hear the welcome speech of Director Universitas Terbuka. Ladies and gentlemen, please welcome Professor Ojat Darojat, PhD.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes to all of us. To our esteemed guests, Professor Insinyur Rijam, MSc PhD, the Director General of Higher Education of the Ministry of Education, Culture, Research and Technology, Professor Soba Raganathan, Professor at Macquarie University, Sydney, Australia, Hollis Abdurrahman Audah, PhD, Associate Professor at Swiss German University, Indonesia, Muhammad Asif Khan, PhD, Associate Professor at Perdana University, Malaysia, Professor Dr. Hafizan bin Juhair, Professor at the University of Sultan Zainal Abidin, Malaysia, Dr. Wasim Haidar, Associate Professor at Central Michigan University, USA, Dr. Ernik Yuliana, SPI, MT, Associate Professor at Universitas Terbuka Indonesia, Vice Rectors, all leaders of Universitas Terbuka. Dr. Subekti Nurmawati, MSc, the Dean of Science and Technology Faculty and all staff, and to all ISST presenters and participants. Welcome to Universitas Terbuka First Annual International Seminar of Science and Technology for Society Development. I thank you for your participations. And first of all, let us be thankful for good health that God gives, so we are able to attend this seminar virtually. This seminar is organized by the Faculty of Science and Technology of Universitas Terbuka and supported by several institutes such as Masyarakat Bioinformatika and Biodiversitas Indonesia and Indonesian Operations Research Associations. On this blessed day, allow me to offer my deepest gratitude to everyone that has spared some time to participate, whether as keynote speakers, experts, presenters, as well as participants for this seminar. Ladies and gentlemen, this international seminar is part of our annual seminar program, which is being held as part of the Universitas Terbuka Dies Natalis, which is celebrated on the 4th of September every year. In our 37th anniversary this year, our Dies Natalis main theme is entitled Developing Human Capital Excellence through Digital Learning Ecosystem. To strengthen that theme, our Science and Technology faculty, which organized the program in the field of science and technology, is holding this international seminar with a theme of Science and Technology for Society 5.0. Distinguished colleagues and guests, humankind's will to improve its quality of life gave birth to several industrial revolutions, starting from the 18th century. As time passed by, the way people manage natural resources and produces various products, as well as services, also revolutionize the means to process and develop them. The Industrial Revolution has evolved during human history from its first around 1760 to the fourth, which we are all experiencing currently. As technology develops, several challenges have come up that humankind has to face. One of those challenges is to figure out how to maintain our current standard of living without giving more pressure on the Earth ecosystem. Many human activities are being influenced by its population number. Human population growth is one of the biggest factors in environmental damages facing the Earth today. The world population constantly expands with 1.05% growth each year. Indonesia has one of the biggest increases in the human populations with 2.32% growth each year. This counts for 3.51% of the total human population growth, on top of being one of the highest populated developing countries and around the world. Ladies and gentlemen, increasing human populations equals increasing needs, such as food and other necessities. Therefore, the need for more land use is greater than ever. Farming and industries will need space to comply with the product demand of the populations. On the other hand, a higher population means the need for housing spaces will also increase. Thus, these conflicting needs will result in more land and natural resources exploitations. Another effect of this increasing housing demand is urbanizations. With fewer land to farm, more and more people will try their luck in the city, hence fewer human resources to take care of the farm. Increasing the urban population will also cause a problem in the city if not anticipated and maintained well. This will give rise to slum area, sanitary and health problems for the community. To deal with these potential and current problems is still difficult to manage with our current technology and way of life. So, we would need to develop a new paradigm that is more human-focused. The thought that quality of life based only on technology is no more optimal in terms of efficiency and value. The question of how to manage and master technology for human development that synergize with the protection of people and the environment has currently been asked. In Japan, this concept is conceived by the government with the help of the academic community to create a society that values and enjoys its life, known as Society 5.0. This thought is a response to the fourth industrial revolutions due to its high technological achievement, but with minimum societal involvement. There is not a huge difference between the two concepts. However, whereas the fourth industrial revolutions relies more on technological advancements and artificial intelligence, Society 5.0 put more emphasis on its human component. Big data and artificial intelligence are being transformed into a new way to aid humankind in a more meaningful way. Distinguished colleagues and guests, based on Society 5.0 paradigm, Science and technology have to help improve the quality of human life without impacting the environment and societal structures. Big data, for example, is being used to solve environmental problems and challenges. Fields of science and technology, such as food technology, agribusiness, biology, urban and regional planning, mathematics, statistics, and information technology play a part in solving these problems correctly and efficiently. Applied science and technology should involve multiple disciplines to efficiently solve problems using different perspectives. To all our guests, those are the few hopes that I want to convey this time. I pray that all of our guests, participants, and organizers of ISST are always blessed with good health and fortune. I hope today will be a moment where we could develop new ideas, exchange thought, and learn new as well as exciting concepts. Whether you are a speaker, expert, presenter, or participants, I and the rest of the ISST team wish you an enjoyable and educational time in this seminar. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Ojat Darojat, PhD, for a very insightful remarks related to the role of science and technology for the Society 5.0. Ladies and gentlemen, we now will have a keynote speech from the Ministry of Education, Culture, Research, and Technology, who in this occasion will be delivered by the Director General of Higher Education, Research, and Technology, Professor Insinyur Nizam, PhD. First, I would like to read Professor Nizam's brief CV. Professor Insinyur Nizam, MSc DIC, PhD IPU ASEAN Eng, as a professor of civil engineering from Gajah Mada University. He earned a Doctor of Philosophy degree from the University of London, United Kingdom. His experience in the field of higher education is unquestionable. He served as a Secretary of the Council of Higher Education from 2008 until 2013. He is one of the people who participate in the core team of drafting the law on higher education in 2012, law of medical education in 2013, and the law of engineering in 2014. He has many scientific publications, and many awards have also been made by him. Professor Nizam was given the mandate as Director General of Higher Education since July 21, and as August 2021, he was appointed as Acting Director General of Higher Education, Research, and Technology at the Ministry of Education, Culture, Research, and Technology. First of all, ladies and gentlemen, please welcome Professor Nizam, PhD.
Assalamualaikum warahmatullahi wabarakatuh. Very good morning to all guests, participants, and ladies and gentlemen. Excellencies, directors of UT, and all participants of this very interesting seminar. First of all, I would like to congratulate Universitas Terbuka for hosting this seminar in Science, Technology for Society Development. Please allow me to share screen. Yeah, so we are now facing with the global challenge of preparing our human resource to meet with the need of the future. To give you a brief overview of Indonesian higher education, we have more than 4,500 higher education institutions in Indonesia, serving close to 8.5 million students by 300,000 lecturers spread all over the country. And this is the challenge that we are facing today, global challenge from the demographic of the world that is aging and growing, and the urbanizations, global urbanizations. Now more than 50% of the world populations live in city, urban areas, with all the problems, all the pollutions, and all the issues related to urban life. And also global trade is getting more and more barrierless. The global financial system also make us intertwine one with the other. And the growing of the middle income populations means more consumption, more needs for consumptive lifestyles. And for that reason, there will be scarce natural resources being sought after by all countries, and that impact into the global climate change. But we know that technology is always advancing, and at the same time, we also see the global change in geopolitics as well as geoeconomy. Now the global economy is shifting to the east. Now more than 50% of global economy is growing in Asia. And it is still growing with the growing of the populations and the growing of the young generations in Asia. Globally, we also face with our pledge to meet the Sustainable Development Goals, to alleviate poverty, to making sure that the planet we live today is still livable for our future generations. And all those come now with the Industrial Revolution 4.0. The Industrial Revolution 4.0 impact many aspects of our lives. Most importantly, our jobs. Jobs are disappearing with coming of automations, robotics, artificial intelligence, areas that usually we are still comfortable with, now being replaced by artificial intelligence, machine learning. So the machine now become able to manage itself, even think, quote unquote. And that makes competencies that we learn become obsolete very rapidly. In Indonesia alone, 23 million jobs will be replaced by the automations and the Industrial Revolution 4.0, the cyber-physical intertwine. But the opportunity for the creation of new jobs is more than the job loss. But many of those jobs still not here with us today, but will be here every time as creativity and technology growing. So it is a challenge for university how to prepare for use of new skills, which is not yet known for all our students. We have to prepare graduates with skills that we don't even know what that skill is about. So we have to prepare them to be more adaptive, more agile, self-directed, entrepreneurial, complex problem solver, digital literacy, and many new literacies that is necessary to live in this fourth industrial revolutions. And multidisciplinary is a must, and global citizenships. And university as the link between the educations and the professional world need to be more agile in developing its role, in transforming its role through education, through research, and through community development, which is what we call a tridharma in Indonesia, the three main role of university, education, research, and community development. All those is very important for every nation, for every country, because the university is a backbone for human resource development, the backbone for innovations through its research, and the backbone for community and society development through its role in the society to impact the society. And we do not want to see university as the bridge between education and the professional world is broken. The link is broken. We have to make sure that what we do through education, through research, community development, and university link with what the dynamics of the world of work, both in research and in educations. So we have to transform, this is Indonesian policy, to transform the narrow perspective of us doing teaching and research from a shallow, very prescriptive way into more dynamic, self-directed, and flexible learning, as well as more interdisciplinary research instead of monodisciplinary, very narrow perspective, very shallow space, into wider way in doing education and research. And we prepare off-campus activities for students. This is to accelerate the preparations or the developing the competencies of students to become more agile and more adaptive with a diverse and dynamic situations in the world of work and the society. We prepare 80,000 of programs for this major off-campus activities as emancipated learning. And we also transform university to become more engaged with industry. So sending students out of campus and bringing professional into campus and sending our professors, our lecturers out of campus. So to intertwine, to marriage between the university and the society and the development in the professional world, and transform our classroom to become more problem-based and case-based, project-based learning. And in terms of research, we will focus on green sustainable development. So green technology, green science and technology, blue, which is marine, because Indonesia, more than 70% of Indonesian territory is sea and ocean. So the blue technology, blue science and technology, in all aspects of science and technology, of course, from social sciences to technology, and accelerating the transformations into the industrial 4.0 to serve the society 5.0. And for that, we have to accelerate the hexahelix collaborations between academia, business and industry, community, finance, government, and media. We thought that collaborations, university will become an ivory tower rather than spring for the development of the society, the development of the industry. So this, to accelerate these hexahelix collaborations, we put resources to facilitate this marriage through incentive for university achieving the key performance indicator, and second, to matching fund for marriage between industry and university, and in collaboration on research and development. We put, if industry commit $1 for those research and development, government will put the same dollar, so dollar to dollar match. And competitive funding to accelerate our university to transform into University 4.0 to serve the society 5.0. And those emancipated learning program of campus activities, we put a big resource there to accelerate our students to go off campus, as well as our lecturers, our professors. That is to make sure that there is a downstreaming and upstreaming from university into the business, industry, and community. This matching fund, basically, it is a platform we already developed and launched this year. And within a short time period, resources that we put in the matching fund Terbuka already sold out. I mean, the call from industry is overwhelming. So they put problems, and university campuses give solutions. So this is the basic ingredients of this matching fund Terbuka. So by that way, research and development and university will be relevant to the need of the society, to the need of the industry. So these are the very important emphasis the government want to put in the policy in research and development. How to make research and development more relevant with the need of the society, with the need of the economy, with the need of the industry, and the need of sustainable development. To brief about sustainable development, we all know that it is a must for us to put sustainable development as a theme in all our research, whatever research that is, in which we address the environment, the culture, the society, and the economy. How education, research, and development should aim at making this planet livable and prosperous for our future generations. So what I would like to emphasize is that all we do in education, in research and development should serve humanity, should serve the planet to make sure that our future generations and ourselves live in a more livable planet. And thank you very much for the opportunity and your attention. And I give back the time to moderator. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Shalom, Om, Santi, Santi, Santi, Om.
Thank you, Pak Dirjen.
Terima kasih, Pak Rektor.
Thank you very much, Professor Nizam, for sharing very insightful update about the issue faced by our higher education sector. Yeah, Professor Nizam, please kindly remain on screen as we would like to give a token of appreciation from ISST committee and also Universitas Terbuka. The certificate will be delivered by our rector, Professor Ojat Darajat, PhD. Therefore, I would like to invite Professor Ojat Darajat, PhD, to give an appreciation certificate to Professor Nizam. Okay. Professor Ojat, would you like to, yeah.
My Honorable Prof. Nizam, as the Director of General Higher Education, this is the certificate of appreciation from Universitas Terbuka. Thank you so much for your involvement in this seminar. Thank you.
Thank you. All the best, Pak Rektor, and all participants.
Welcome, Bapak.
Thank you, Professor Ojat Darajat and Professor Nizam. Now we would like to invite both of you to have a photo session, which will be done virtually. Yeah. Okay, maybe our IT team will lead.
Okay.
Yeah.
3, 2, 1. Okay, done.
Okay. Thank you very much once again, Professor Nizam, for coming, joining us this morning, and Professor Ojat Darajat, PhD. Thank you very much. Ladies and gentlemen, let's move forward to our next agenda, which is will be the launching of ISST book entitled Science and Technology for Society 5.0. Let us watch the following book launching video.
Universitas Terbuka merupakan perguruan tinggi negeri yang menyediakan akses pendidikan tinggi jarak jauh yang berkualitas bagi seluruh lapisan masyarakat. Dalam mengemban misinya, UT melakukan dan mendiseminasikan berbagai kajian keilmuan untuk menjawab tantangan kebutuhan pembangunan nasional. Melalui Fakultas Sains dan Teknologi UT, sejumlah inovasi sains dan teknologi telah dihasilkan. Di ulang tahun UT yang ke-37, Fakultas Sains dan Teknologi UT mempersembahkan buku dengan judul Science and Technology for Society 5.0. Buku ini diluncurkan bersamaan dengan seminar internasional perdana oleh FSTUT, The First International Seminar of Science and Technology atau ISST 2021. Buku ini berisi beragam ide, pemikiran, kajian, maupun hasil penelitian para dosen FSTUT sebagai wujud kontribusi dalam menghadapi era Society 5.0 dari sudut pandang berbagai bidang ilmu. Society 5.0 atau Masyarakat 5.0 merupakan konsep yang dikenalkan pertama kali oleh pemerintah Jepang, yang menekankan bahwa teknologi harus menjadi bagian dari manusia itu sendiri. Konsep Society 5.0 merupakan penyempurnaan konsep Society 4.0. Pada masa Society 4.0, era informasi yang berbasis otomatisasi dan digitalisasi teknologi justru mendegradasi peran manusia. Sebaliknya, melalui Society 5.0, kecerdasan buatan yang memperhatikan sisi kemanusiaan akan mentransformasi jutaan data yang dikumpulkan melalui internet pada segala bidang kehidupan menjadi berbagai alternatif solusi di masyarakat. Terdapat 14 artikel dalam buku ini, yang merupakan karya ilmiah 26 penulis dan mewadahi 3 topik utama. Topik pertama, Big Data Science and Information Technology. Topik kedua, Food Security and Health. Topik ketiga, Biodiversity for Sustainable Environment. Topik pertama, Big Data Science and Information Technology. Karakteristik dalam Society 5.0 adalah adanya pemanfaatan big data dan teknologi informasi yang membantu pengambilan keputusan di berbagai bidang. Dalam buku, secara spesifik dijelaskan, big data digunakan untuk simulasi pengadaan bahan mentah dalam suatu industri. Analisis big data juga digunakan untuk menentukan hubungan kekerabatan sekuens protein virus dengue di bidang kesehatan. Sementara itu, dalam bidang pendidikan, big data digunakan antara lain untuk memprediksi jumlah mahasiswa baru. Topik kedua, Food Security and Health. Di era Society 5.0, kebutuhan pangan yang terus meningkat membuat industri pangan harus berkembang ke arah yang lebih produktif dan bermanfaat untuk kesehatan. Teknologi computer vision sebagai metode analisa kualitas pangan yang bersifat non-destruktif yang menjanjikan untuk dapat mengolah pangan secara cepat dan hemat di masa depan. Penggunaan teknologi pengolahan dan pengemasan yang modern dapat meningkatkan nilai minuman tradisional yang bermanfaat untuk kesehatan, seperti wedang uwuh, teh talua, dan juga bir peletok. Terakhir, dukungan terhadap terwujudnya Society 5.0 dapat dilakukan dengan menggali potensi komoditas lokal. Kajian dan pengembangan riset terhadap komoditas lokal Bligo yang berasal dari suku Labu-Labuan sebagai pangan fungsional dan produk bernilai tambah. Topik ketiga, Biodiversity for Sustainable Environment. Berkurangnya keanekaragaman hayati, menipisnya sumber daya alam, dan kerusakan lingkungan merupakan permasalahan global yang harus diatasi. Dengan pendekatan Society 5.0, perkembangan sains dan teknologi harus selaras dengan kelestarian lingkungan. Pemanfaatan biologi molekuler untuk mengkaji perubahan genetika mikroba pada keadaan mikrogravitasi dan radiasi ion dalam penerbangan di angkasa luar, serta konservasi kehidupan paus biru dibahas dalam buku ini. Berbagai inovasi dalam pemanfaatan teknologi untuk keberlanjutan sektor pertanian dan kesejahteraan pelaku agribisnis di era Society 5.0. Inovasi nilai dalam agribisnis dapat meningkatkan nilai jual suatu komoditas yang berlimpah. Sebagai contoh, dari bunga krisan potong, bunga krisan kering, dan teh bunga krisan. Inovasi sistem pemeliharaan ayam untuk menghasilkan ayam yang lebih sehat sebagai sumber protein. Pemanfaatan limbah pertanian untuk pertanian organik, misalnya pemanfaatan tandan kosong kelapa sawit yang diolah sebagai pupuk organik. Penyediaan lahan padi sawah dari konversi lahan kelapa sawit yang kurang produktif dapat mendukung kebutuhan pangan penduduk yang terus meningkat. Terakhir, upaya lain untuk meningkatkan kualitas hidup secara berkelanjutan adalah peningkatan ruang hidup masyarakat melalui pengembangan kota berbasis Smart City. Buku Science and Technology for Society 5.0 merupakan bentuk kontribusi FSTUT untuk dapat mewujudkan setiap manusia serasa menggenggam dunia melalui teknologi dengan tetap menjaga kelestarian alam dan lingkungan. dan tentu saja akan mewujudkan masyarakat super cerdas, bahagia, dan sejahtera.
Thank you very much. Next, we will give the ISST seminar book symbolically to the Rector of Universitas Terbuka, which will be delivered by the Dean of Faculty of Science and Technology to Rector of Universitas Terbuka. Thank you, Professor Ojat Darojat, PhD, and Dr. Nurmawati. Ladies and gentlemen, we finally arrive at the main agenda in a few moments is plenary session. We will listen to the presentation of current issue related to our theme, Science and Technology for Society 5.0. The plenary session will be divided into two subsessions. First session of the plenary will be moderated by Mr. Fauzi Rahmadian Zuhairi SSI MSc, and the second session will be moderated by Dr. Anak Agung Made Sastrawan Putra MA ADD. Without any further ado, I would like to invite Mr. Fauzi Rahmadian Zuhairi SSc to guide us through the first plenary session. But first, I would like to introduce Mr. Zuhairi. Mr. Zuhairi graduated from Biology Study Program, School of Life Science and Technology, Institut Teknologi Bandung. He researched influenza virus internationalization for his thesis. Mr. Zuhairi continues his master study on molecular bioscience and biochemistry program, Department of Bioscience, University of Oslo in 2017, with master thesis topic in silico and biochemical characterization of novel human methyltransferase 13. Currently, Mr. Zuhairi is assistant professor in biology study program, Faculty of Science and Technology, Universitas Terbuka. Please welcome Mr. Zuhairi.
Yes, thank you very much, Ibu Fenty Fitriani Nurunisa, for the very nice introduction. A very good morning to everyone, honorable guests, speakers, presenters, and participants of the first international seminar of Science and Technology, Universitas Terbuka. We wish you all the very best health during the global COVID-19 pandemic. And as mentioned by the MC, my name is Fauzi, and allow me to guide this plenary session 1. So for this first plenary sessions, we will have 3 lectures. First will be delivered by Associate Professor Muhammad Asif Khan, PhD from Perdana University, Malaysia, and Bezmi Alim Fakih University, Turkey. And second will be given by Associate Professor Hollis Abdurrahim Audah, PhD, from Swiss German University, Indonesia. And the third lecture will be given by Professor Shobha Ranganathan from Macquarie University, Australia. And please allow me to greet from Indonesia to all the 3 speakers, Professor Han, Professor Audah, and Professor Ranganathan. We are very grateful that all of you are able to give live presentation today, and we wish you all a very good health. And one note to all audience before we move on to the first lecture is to prepare the question for the question and answer session or Q&A that will be held after the third speakers or the end of the plenary session 1. And we can put or type question in the chat box. And don't forget to put your identity in the question and to whom the question is asked for. And also one important note is that to all audiences is not allowed to put any mark without the committee permission during the speakers and presenters presentation. And if possible, to all the speakers and presenters to choose a menu of disable note to prevent such thing. So now we will have the first lecture for the first plenary session from Associate Professor Muhammad Asif Khan, PhD from Perdana University, Malaysia, and Bezmi Alim Fakih University, Turkey, with the title of the presentation, Biological Data Warehousing and Bioinformatics for Society 5.0. But before the presentation, allow me to read the brief CV of Professor Han, as we may see in the main monitor now. Perhaps the IT team can give the spotlight to the CV. Yes, thank you. So Professor Asif Khan is a recipient of the prestigious 2232 International Fellowship for Outstanding Researchers awarded by the Scientific and Technological Research Council of Turkey, or TÜBİTAK, and he is currently hosted as a visiting professor by Besmialim Fakih University, Turkey, while maintaining his faculty position as an associate professor at Perdana University, Malaysia. He was the founding dean of the School in Data Sciences and founding director of the Center for Bioinformatics, both at Perdana University. His research interests are in the area of biological data warehousing and application of bioinformatics to the study of immune responses, vaccines, inhibitory drugs, venom toxins, and disease biomarkers. Dr. Han has published more than 75 articles and has developed several novel bioinformatics methodologies, tools, and specialized database, and currently has 3 patent applications granted. He is currently the elected president of the Asia Pacific Bioinformatics Network, or AppBioNet, one of the largest and oldest bioinformatics organization in the region. So, Professor Han, without further ado, you may start the 20-minute presentation now.
All right, thank you very much. Let me just share my screen. Okay. Okay, can you see the slides?
Yes, it's very clear from us.
All right, thank you very much for the kind introduction and the opportunity to be part of this special event. So I'm joining all of you from Istanbul, Turkey, and it's right now 5 in the morning. So I've been up since night. I was worried that I might not wake up. So if I'm sleepy or if I start mumbling, just let me know. All right, 20 minutes. I think I have more material, so I'm going to speed up. So as you can see the title, I'm not going to repeat the title. I'm going to just dive in. This has been covered. What does Society 5.0 mean? I think we all are familiar with the definition of this. I just wanted to go through again just to make sure everybody is clear. And I actually highlighted, so underlined what kind of attracted me about Society 5.0. So number one, it's human-centered. I think that's a great idea, and it should be at the end of the day, things that solve human problems. So I think that's a great way forward. A human-centered society, and the other thing that I liked was the word balance. So I think striking a balance is always a challenge. And, if in 5.0 we can strike that balance between economy and social problems, I think that's something we all look forward to. Sometimes it's just lopsided one way or the other. And the other thing that kind of attracted me to this concept is that all this is going to be done through a system. So I think that's where my talk is going to be focused on. So there's some sort of a black box, not exactly a black box, basically a system that will facilitate this whole process for us, help us. And it could be in the form of AI robots, AI machines, and whatever else you have out there, and that will come or that's already there, that's going to facilitate all this. So I think that to me, in essence, captures the gist behind Society 5.0. And this is just to further recap, we just didn't jump into Society 5.0. We actually, if we look back, we have gone through various transitions. So, as you can see, starting off as hunting society, then agrarian society, eventually to the industrial society. And that kind of paralleled with industry 1.0, and then we became information society, and that was kind of parallel to industry revolution 3.0, and today we all know we are industrial revolution 4.0, and this nicely corresponds to Society 5.0. So this Society 5.0 needs to be supported by that system, and that system is fueled by industry IR 4.0, and I think it's a very nice combination, and it promises there is hope for achieving Society 5.0. Although I must say that the goals are really very lofty and something that I may not see in my own lifetime, but it's definitely good to start working towards that from now. All right. So having covered all that, I think the next area I want to zoom into, given my title, is bioinformatics. I want to introduce bioinformatics to all of you. So I'm not sure, given the audience, how familiar you are with bioinformatics, but again, just to be sure we cover the bases. You must have heard bioinformatics from the news. It's really out there. It's actually a form of data science for life science. You can think of it as that. So, but more specifically, it's a bedrock of current and future biotechnology. So, if you are doing biotechnology, you should be familiar. And one of the complaints I have is there's just not enough bioinformatics in biotechnology curriculums. So, those who teach biotechnology, you may want to consider increasing the load on bioinformatics, because I really think it's important. It's a key driver of life science research, and it's going to be just more and more important. So if you are in life science, you cannot run away from doing this. So better start exploring this now than much later and be left behind, right? So it's a data science for life science. It's in some sense, and data science is it's a lifeline for IR 4.0. And there are all kinds of articles you can read about why this is very important. Now, again, formally, just to be clear, what is the definition of bioinformatics? It is the development and application. So there are two keywords to be noticed, to be taken note there: development and application. Why I want to emphasize is often people just think about the application. So if you use blast search, for example, that doesn't really make you a bioinformatician. You are more of a user of bioinformatics. So you've got to really, be involved in the two parts, which is develop and apply. Sometimes there's nothing, no tool, no database, you got to develop it, right? So basically development and application of all kinds of techniques, I don't want to say from where, it can be from anywhere to solve biological problem. So develop, apply anything out there to solve a biological problem, that's bioinformatics. Of course, and what we apply is typically computer science, mathematics, statistics, etc. So that's the operational definition. There is a philosophical definition, which is it is the study of information content and information flow in biological systems and processes. To many of you, this may not be familiar. To many of you, this may also sound like biology, biology 2.0 maybe, but biology essentially. Now, what would be information content and information flow? So bioinformatics actually allows you to look at biology from the lens of information theory. So what is information content? If you take the cell, for example, the content would be your DNA, your RNA, your protein, that's content. Flow would be how does the DNA change to RNA? How does the RNA change to protein? So you have, transcription, translation, post-translational modification, etc. So that's the process, and together these actually, these drive biology. So the study of the content and the flow is what bioinformatics is all about, and this is important because in the year 2000, you heard about the human genome sequence being completed, and only recently actually the full genome was kind of formally completed. Although in 2004, I think we already had more or less a full one there. Anyway, so we had the content. So the genome can be considered the content, but we didn't really fully understand the process. That's why 22 years later, we are still struggling. We still haven't really cured or understood a lot of diseases. That's because the process is even more complicated, and we're always learning something new. So it's the combo of the two that will actually help us, solve problems, biological problems moving forward. So I hope with that you're much clearer what exactly bioinformatics is all about. And you can actually break it down: data warehousing, data mining. My topic for today's lecture, today's talk is actually data warehousing. But you can't really separate data warehousing from data mining. So I'm going to briefly cover the two. I'm going to emphasize on data warehousing. So you can simply think of bioinformatics as data warehousing, data mining. What is data warehousing? Well, we study data. So data has to come from where? So the biology part is actually the data, your DNA, your RNA, your protein, you name it, that's data. But we don't study data as it is. The data must be stored. Otherwise, it's just going to be a big mess. So you take the data, you put it in a warehouse or database. Now they call this knowledge bases or living databases. These are some of the buzzwords at the moment. So you put this data in these databases, and then we can start mining. Now, the databases, of course, help you find, you don't want to waste a lot of time just looking for what you want. Google these days is so smart. Even before you type, it already knows what you want. Did you mean this? So that's the kind of databases we want for biology, where, it just gives you what you want very quickly, so you can, focus on the data mining. You don't want to waste so much time on the warehousing and instead focus on the mining, because we have mountains of data and it's like looking for a needle in a haystack. So we definitely need to spend a lot of time on that. All right. So, okay, sorry about that. So in a nutshell, bioinformatics actually underpins integration of biology to handle this complexity of biological data from 1 dimension to 2 dimension to 3D structures and even 6 dimensions. So it transcends across these dimensions. And for every wet lab aspect that you have for biology, there is you will actually find a corresponding dry lab version of that. So they work hand in hand to push discovery, knowledge discovery forward. And as I mentioned earlier, actually bioinformatics underpins all kinds of research. So you really cannot run away from this. Now, moving to the database part. So in the past, many of you may be able to relate this. This is actually a slide from my former supervisor about, close to 20 years ago. So typically you do experiment, you get result, you publish. That was the cycle. Then back then it was the present, but now it's no longer the present. I call this the recent past. Then databases became the middle part. So you do experiment, you get the results get deposited in databases. Journals used to twist us, so we would have no choice but to put it in the database. Otherwise, they won't publish your papers, which I think was a good thing because it's really opened up a lot of opportunities. So anyway, you got databases, then you learn, you gather information, you design your experiment, then you go through this cycle. And then in this, I call, this was back then emerging trend. Now I think this is a trend. This is already a present. This is the present at the moment. So you do your experiment, you get a result, it goes to the database, then you use tools to make your experiments even more targeted, more precise, so you don't waste time, you don't waste money, you improve the efficiency of the discovery process. All right, so this is the present in some sense, but not exactly the current present, but we're actually shifting away from that. But think of that as the present that has been around for quite some time, right? So, and what encapsulates all of this is actually a data warehousing framework. What exactly is a data warehousing framework? See, the thing is, when we don't have this framework, bioinformatics research may end up becoming very ad hoc. You have a biological system, you apply the tool, you make sense of it. That's it. That's what a lot of people do. But if you do this systematically, you can actually maximize so much more from such an analysis, so that you can actually build upon that and generate more papers. Rather than just one paper, you can actually generate more papers out of that work, and it can benefit your future team members so that they can actually build upon that work. So the systematic would be, you have your biological system, you create a formal description, you treat it like a mathematical problem, then you apply your computational solution, and you standardize the results, then you make biological interpretation. So this systematic way would actually allow people to, new people to come in, they understand what exactly is happening, so they can take it forward. You don't waste time just trying to figure out where is what does what mean, etc. Right? So that's something we, that's where we should be heading towards, and most people are already doing that. These are the various steps of the warehousing. So we have to, of course, retrieve the data, clean the data, integrate the data, annotate the data, build your database, and you also need to think about updating your database. Then you do at the end data mining. So it's like out of 1, 2, 3, 4, 5, 6, 7, out of 7 process steps, 6 of them are just janitor work. In fact, there's a joke, bioinformatics or data science is a lot of janitor work rather than the actual analysis. The actual analysis is kind of the short part, the fun part. The boring part is the data cleaning, but the more essential one. I like to call that data honeymoon. Anyway, so data warehouse, is basically a warehouse of a system. So Society 5.0, the word system. So we say, think of it as a system that enables extraction, synthesis, and complex analysis of data, which supports decision-making and extraction of new knowledge. And this has been around. So even during Society 4.0, what's the difference is that in Society 5.0, you actually going to make this even more smart society. So you end up using AI, machine learning, learning, deep learning, some of these buzzwords to really speed up, improve the quality, of what comes out of this, and be able to predict in the future what's going to happen. So that's kind of the difference between 4.0 and 5.0. And some of the problems, that we, in order to get to that, is data explosion. So big data, a lot of data coming up. And this is where actually AI does a very good job. Deep learning especially is very good at managing big data. Quality of the data is another issue, fuzzy and complex. Biological data are very fuzzy, very complex, all kinds of interpretation. So you can have inconsistent, inaccurate, redundant, irrelevant, incomplete, incorrect. So cleaning is very important. And this is where also, AI and machine learning, sometimes they don't really need a lot of that. They can manage without a lot of this cleaning. Of course, the more the cleaning, the better it will get. But some of these systems are able to kind of overcome the need for that. And integration is another area that actually was emphasized a lot. And this is also some of the areas that these AI machines are able to, overcome by for example, you could have columns of 200 different columns of data, and they will be able to take all that data and analyze and look for important aspects of that data that could be used for actionable insights. Of course, we cannot run away. I'm not trying to say that we don't need all that to be done anymore because of AI, but AI makes doing all this much easier. But it's not just AI. AI is not the only part of this. Actually, you still need standardization and all that stuff. But in some small steps, AI is helping to make that a little easier. All right. So, and of course, database creation and maintenance is becoming more of a routine these days. A lot of younger people who do not know much actually are able to create databases. So this is actually becoming quite simple, straightforward. Anyway, so this is a summary of the data warehousing goals that needs to be achieved. And I think you can read that. Okay, so I'm going to now quickly move to, provide an example of how this can be done for something like the current pandemic that we're dealing with. So these are just the latest numbers. I don't want to, make us sad by reminding you of the numbers, and we're all quite familiar. I just want to showcase how the data for SARS actually has grown, not just for SARS, actually viruses. So in 2018, we had like 4.9 million protein sequences. And by 2021, we had 11.3 million protein sequences. So that's a big jump of 129% over, just a period of 2019, 2020, about less than 3 years. So much more data than it was actually there back in 2018, even more than when it was there, right? So the percentage increase is huge. So data, it's a real problem. It's growing like crazy, and because of SARS, it's just grown even more. And a lot of this is because of the next generation sequencing, which is making it really easy to sequence all this. And it is said that by 2025, biological data is going to be the largest data out there. Right now, you may think of astronomy and Twitter, YouTube, and all that. Genomics alone by 2025 will have much, much more data than a lot of these. And if you combine that with health, it's going to be even more health-related, hospital-related data. All right, so 2025 is not far away, and we got to be really prepared for this. And if you do not know what does PB mean, PB means petabyte. So you all must be familiar with terabyte. So petabyte is the next level, and there's like exabyte, zettabyte, yottabyte. So these are the big data scales that we are really talking about. I'm already aware of some people, some organizations that are dealing with zettabyte of data. Biology at the moment is in petabytes, and soon it will be in exabytes. So in terms of data mining, actually, there are a lot of tools that are already developed for bioinformatics. Just for Corona alone, there's actually a website that lists all the tools that are relevant for Corona. This is the website, and there are like 100 plus tools over this short period of less than 2 years that have been quickly developed to solve all kinds of different problems. So you can see that the society is really, really, really mature to be able to respond very quickly. And I think a lot of the vaccine that we've seen, it's in big ways helped thanks to the bioinformatics developments. And but essentially, again, Society 5.0 should move away from just dealing with information, but to really knowledge and wisdom. And that's what we should be gearing towards. And for something like that, integration is the key. Machine learning and some of these latest technologies that allow us to deal with all this, Web 2.0, machine learning, AI, deep learning, are making all that happen. For example, you may have heard of AlphaFold, this AI system that is actually helping us solve 3D structures. And that's a big leap, and it was a big news just very recently, and it's open source, so people can look at it, people can use it, and that's the kind of society that we are talking about. Things are open, so people can work on that, build on that, and I think they're making a lot of progress on that. Here's just to demonstrate that the real future for Society 5.0 would look something like that. You have databases, you have tools, all interconnected, working kind of together in harmony to bring about findings, results, discovery, so we can actually solve these problems. In the case of precision medicine, which is bringing these benefits to patients, you can see this is actually a model of how it should look like. The data integration, you still need standardization, processing, annotation, analysis, visualization, and you have data coming. It's a multi-dimensional molecular profiling, from sequencing, mRNA profiling, genotyping, microRNA, epigenomics, proteomics. And you pull that data, you integrate with clinical and pathological data, you integrate with experimental data, and together you analyze, and then you come up with candidates, drug candidates, vaccine candidates that can be used for those patients in a personalized way. So personalized medicine is another buzzword, which will happen, I think, thanks to bioinformatics and thanks to these technological developments that are happening. Here's an example of how, again, tools are put together in a workflow environment, automated to bring about these benefits. So that's the pattern. That's the pattern, at least I foresee for bioinformatics in this era of 5.0. That's where we are going, and this will result in a lot of applications that you can see here. Of course, this is still not perfect. There are problems here. Here's an example of a project actually that I am involved in. It's a flagship project, and this is the project I'm funded for in Turkey. So we are trying to do something similar. We are trying to build a system that will take this data that's being deposited in the public repositories automatically, real time, take that data, do the janitor work, cleaning, instead of human, automate it to be done by machines. And after that's done by machines, analyze it automatically. And then if something interesting is something different from the previous data, then you create an alert, and then you send that alert to WHO or whoever is responsible. So then actions can be taken. People can come and see what's going on around the world, different countries, what are the viruses, whether there's a big change, big jump in the diversity of the viruses. And so this is a platform that I am hoping to build, by 2023, and to share with the world, so we can learn more about viruses, take actions very quickly, automatically, so that we can be more prepared for the pandemic in the future. All right, so of course it's all not rosy, it's not perfect. I'm almost finishing, so it's not perfect. There are problems, there are issues that we need to deal with. So I personally think we are still very far away from Society 5.0. That's why I said early on, it's a nice vision, and it's something that we should start working from now. At least we have a vision, we have a roadmap. But there are challenges that need to be worked upon, and there are people who are working on this. So first challenge, locating data, software tools. I mean, there are just so many people who still do not know where to get the data, what are the right tools to use for the problem that they are dealing with. Getting access to the data. Sometimes these data and the software are not freely available, not open source, so a lot of things we can't do. Usually they're very good, but they are, we are kind of barred from access unless you pay a lot of money. So that's another problem. Standardization is still very much lacking in biology, although there are big efforts towards that. There's much to be desired, but it's definitely a progress there. Policies and practices for data and software sharing of data is still another. Hospitals are kind of restricted, limited in sharing. We don't, often have this EHR, electronic health record, countrywide. It's because of data privacy sharing issues are all something to be looked upon, the ethics behind all that. And of course, better ways of organizing, managing, and processing and cleaning that biomedical data is still not perfect because of the fuzzy nature of biological data and the different types of biological data that you have to deal with. Coming up with new methods for analyzing and integrating data, and more importantly, or last but not the least, is training people who can use this big data effectively. And I think training itself is a big lack, especially in Southeast Asia. All right, so again, just to remind you. Yep.
Excuse me, Professor. Yep. I think we have approximately 1 minute left from the timeline. Okay. So yeah, I apologize. We apologize. Yeah.
No problem. I'm done. Again, this is just to remind you that there's a big explosion. So I hope some of you who haven't decided what you want to do with your life, with your future, come and do bioinformatics. All right. Thank you very much.
Thank you very much, Professor Han, and maybe we can give a round of applause, virtual applause in the Zoom chat. And yeah, Professor Han, we are very grateful and happy that you are present here, even though it's still 5 or 6 a.m. in the Istanbul. And
5:30.
Yeah, and I think it's a very comprehensive lecture in which I believe that it may require more than 20 minutes to sufficiently deliver such a very interesting topic to all the audience. So yeah, so we hope that it will be possible for some of us, lecturer and scientists from the audience and the Universitas Terbuka, to have further discussion with you by email, etc.
I look forward to that. Thank you.
Some of the note that we may highlight are the importance about the bioinformatics is that it's a development and application of interdisciplinary techniques from computer science, mathematics, and statistics to address biological problems. Especially for solving all problems related to build a better society 5.0. And the technique in data warehousing and data mining will provide the framework of a present life science research trend, which is more efficient by having a cycle of utilizing database, moving on into the in silico, and then further into targeted experiment. And Professor Han, we will have a Q&A session at the end of the first plenary session. And for all the audience, we remind you that please prepare the question for the Q&A in the Zoom chat box. And don't forget to put your identity in the question and to whom the question is asked for. So thank you very much, Professor Han. Now we move on to the second lecture, which will be delivered by Associate Professor Dr. Hollis Abdurrahim Audah from Swiss German University, Indonesia. Entitled The Role of Telemedicine During and Post-Pandemic Era. And before the presentation, allow me to read the CV of Professor Audah, as we may see in the main monitor now. And yeah, so Professor Hollis Abdurrahim Audah, PhD, earned his PhD in biochemistry from Auburn University, Alabama, USA, and he did his postdoctoral research at Yale University School of Medicine, USA, at the Department of Internal Medicine in the area of infectious disease. He is an accomplished protein biochemist with interest in biomedical research and development, such as microbial defense mechanism and drug discovery from natural products, and student research and community service engagement with more than 10 years of managerial experience with proven leadership and communication skills, and also has a broad international exposure in networking and promote diversity at workplace. So, Professor Audah, without further ado, you may start the 20-minute presentation now.
Thank you very much, Pak Fauzi, for a very nice introduction. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, ladies and gentlemen. Thank you very much for having me here today. So what I'm going to talk about today is about, let me just share my screen. Everyone seeing my slide right now?
Not yet, I think it may in progress.
Is it okay now?
I think it's still on progress. Now it's, yeah, now we can see the slide.
Thank you very much. I enjoy listening the talk from Asif Khan. Luckily, I didn't talk about bioinformatics because I would not dare enough to talk about bioinformatics in front of the Prof. Han and also Prof. Soba, so the guru of bioinformatics in the regions. Although I'm also promoting bioinformatics in Indonesia, today's talks is going to be about the importance or the role of the telemedicine during and post-pandemic era. So I think let me just all right. So we all know that we are in a very difficult situation in the last year and a half due to the pandemic, coronavirus pandemic. It has become a very difficult and hard burden for all of us, and we have to come up with a solution, that will help us to go through this difficult time in all aspects of life, including in medicines. So the reason why I'm talking about this, the importance of telemedicine during and post-pandemic era, because actually echoing what Prof. Han today's talk recently, just now, that today's era is about information technology era in many aspects of life, including in biology, in medicine, in economics, and so on and so forth. So please allow me to deliver the talk about that today. Let me introduce myself again. My name is Hollis Abdurrahim Auda. I'm a senior lecturer at Swiss German University. So I'm also in the biomedical department, engineering department. So let me just introduce briefly about the university. SGU, Swiss German University, is a small private university. It's the first international university in Indonesia, founded in the year 2000 as private initiative, Indonesia, German, and Switzerland. We only have, please don't compare with Open University Indonesia, Universitas Terbuka Indonesia. Yeah, we only have about 11 bachelor degree and 3 master programs. And my department is in the biomedical engineering department. So actually biomedical engineering department in SU is the first of a kind in Indonesia. But in 2015, government start opening the same study program in some public university in Indonesia. So our instructions in English and German as second foreign language, and we have about around 200 full-time staff. So this is what I'm going to talk about today. What is telemedicine? I believe that many of you or some of you have learned about or familiar with telemedicine, but there is nothing wrong with refreshing our memory about what is this. And then driving factors of telemedicine applications, telemedicine in the context of Indonesia, and also telemedicine case. The reason why I give you this topic today is because I'm also working on a research project. Hopefully Prof. Nizam is still here because Prof. Nizam through Kedaireka funded my project in telepathology for cancer detection. I also work on the development of Indonesian biodiversity database, both website and application based, and also in both two ways, in a more scientific and also popular database. And of course, I would conclude my talk with conclusion and future direction and acknowledgement. So what is telemedicine? Telemedicine, as we know, literally, in the literal meaning, is a healing at a distance. So the firstly coined in the 1970s. So by this very simple meaning definition, it's not a real definition, it's really a literal meaning, healing at a distance. We directly know that distance, it means that it needs something. It takes something to do this kind of things, which is actually information technology. Yeah. So by definition adopted by WHO, telemedicine is the delivery of healthcare services where distance is a critical factor. So we will try to fit this in Indonesian context, how telemedicine is very important in the context of Indonesia. So where the distance is a critical factor by all healthcare professionals using information and communication technologies, I put some highlights here, for the exchange of valid information for diagnosis, treatment, and prevention of diseases and injuries, research and evaluation, and for the continuing education of healthcare providers. All the interests in the interest of advancing the health of individuals and their communities. So, although the term is more very rigid to the medicine, but actually the application is very much very wide. Yeah, but of course there are some keywords that we need to address in terms of telemedicine. The first is because of the distance. We have limitation in distance, and also the application of information and communication technology, and of course the valid information exchange. The telemedicine covered a wide range of application, and of course the three main aspects of medicines, which is diagnostics, treatment, and prevention, will always be covered through telemedicine, or will always be the main focus of telemedicine. But in addition to that, research and evaluation and also continuing education can also be included in telemedicine. So now we know that the object or the area covered by telemedicine is not only about curing disease of certain patients, but also different aspects related to the diseases, including continuing education for the healthcare providers. So what are the different the driving factors for telemedicine applications? As I briefly mentioned about, the first and of course is the human resource limitation. Limited healthcare professionals will drive the need of or the application of the telemedicine, and also an even distribution of healthcare professionals. These two conditions, the first one, human resources, are very much alike or very much relevant to Indonesian context, whereas Indonesia have a very limited healthcare professionals. And then to make the thing worse is because the healthcare professionals are not evenly distributed, yeah, in Indonesia. As we all know that the majority of people live in Java Island, as well as the experts, the healthcare professionals, majority of them live in Java Island. The second part is actually the accessibility, yeah, remote areas and infrastructure. This is also very relevant to Indonesian context. We know we have more than 13,000 islands. Yeah, some are very remote, yeah, areas that cannot be accessed, yeah, by any transportation, yeah, easily, yeah. And as well as infrastructure, we are not ready with the infrastructure for any kind of infrastructure. So these things drives the need of telemedicine application. And also mobility. This part, the mobility part, is actually the part that are now being very relevant. Yeah, the mobility because can be caused by the poverty, lack of resources, no money, no funding to support the healthcare, and also now right now, such as during pandemic situation, our mobility are very restricted. Yeah, with the PPKM lockdown and so on and so forth. So we cannot even go to grocery stores, for example. Yeah, so we have to think twice if we want to go to hospital, for example, because of the pandemics, as well as wars. Well, actually, the pandemics and wars is a very slight difference. Yeah, the situation of the pandemics is just like the situation during the wars. Our mobility are very much restricted due to this context. So having said all this, we try to fit this telemedicine, the driving factors in the context of Indonesia. Now we know that Indonesia has about 280 million people in 2020. Yeah, she's the fourth largest country in the world in terms of population. So this is very much relevant to us right now. And then uneven distribution of population, mostly in Java, including healthcare professionals. Yeah, I will give a case study that I'm working on right now, why I work on this. And then geographical location. We have a very small island, remote areas all over Indonesia. And sometimes can only be reached by either water or by plane. For example, in Papua, yeah, in remote areas such as Papua and other islands, which are far away from Jakarta. And also the poverty level. Indonesia still have a very relatively high poverty level. Yeah, well, it depends. It really depends on what standard you want to use. Yeah, the poverty level. So all these factors really drives, we have to think about the importance or the application of telemedicine in Indonesia. So all these conditions apply to Indonesian context that push us, you will like it or not, that we have to apply telemedicine. Now, thanks God, due to the pandemics, we know, or some already, for example, holodocs. I'm not promoting holodocs, but holodocs is one type of the application of telemedicine. So I would like to share with all the audience today about what we have been doing in the last few months. It's about establishing or development of telepathology for cancer detection, which is part of telemedicine case study in Indonesia. In terms of cancer disease, we all know that cancer is one of the most causing death disease, not only in Indonesia but also all over the world. But in terms of the availability of pathologists, we only have about 1,685 clinical and anatomical pathologists. This is according to the Ministry of Health Indonesia in 2020. So you can imagine that out of 280 million people in Indonesia, we only have about less than 1,700 pathologists. So you can imagine the ratio between the expert and the populations. So it reaches about 1 to 160,000 ratio. This is a lot higher than German, for example, 1 to 47,989, in Malaysia 1 to 103,000. So it means that we have a very limited resources in terms of pathologists, but also, of course, it opened up the opportunities either for those pathologists or for people who want to be pathologists in the future. It's just a matter of on how we use technology to provide a better healthcare with such limited resources. And then out of this 1,685 clinician pathologists, about 58% are in Java Island. So you can imagine, out of this 1,685, about 58% are in Java Island. And how the people outside Java, especially remote areas such as in the eastern part of Indonesia, get benefit, out of this 1,685 people, pathologists, to really utilize, take advantage of the technology using telemedicine approach. And then, of course, Indonesia has also have a limited mobility accessibility in some areas. For example, in one district, maybe only one OB-GYN or maybe only one pathologist. How can one individual, a single pathologist, serve maybe around hundreds of thousands of people? You can, because the rate of cancer disease are very high even in Indonesia. So in answer to that need, we in our lab propose a research project through a matching fund by Kedai Reka and in collaboration with Neurabots. Please try to understand this is also very highly related to data science, because biomedical data in Indonesia is pretty much untouched, have not been yet explored. So you can imagine out of 280 million people, how many million people visited hospitals every single day? So you can think about how much data stored in our hospitals. Even the hospitals now complain about we don't have any more space to store any of our samples, for example, in microscope slides and everything, because we usually use more physical storage rather than soft storage. So we try to reduce these problems by creating or making what's so-called micro scanner. Telepathology microscope scanner technology development for cancer detection. Okay, so this is just a small simple background about cancer, especially breast cancer. we in Indonesia have a very high prevalence of cancer disease. Yeah, and the breast cancer is the highest one. We also have a very limited number of pathologists. That's why we have to maximize the use of the pathologists in order to reach remote areas utilizing technology, information and communication technology. We also have, with the current technology, we have a very limited speed of detection because we use a traditional microscope that we have to change the focus every time we want to take picture, for example. And of course, it has a very relatively low accuracy because it really rely on the bare eyes of the pathologist. What we are trying to do is to improve these tools, for example, in the terms of microscope, and how we convert this microscope into microscope scanner, so we can get a faster pace of detection, a more accurate and also affordable instruments. Yeah, and more importantly is can cover a large areas of service. Yeah, we can put these instruments in remote areas, but the pathologists no need to go there. So you can just utilize the internet, the ICT facilities, and then the sample will be learned by the pathologist elsewhere, for example, in Jakarta or any other big cities. So they don't have to go there. So the instruments is called microscope scanner because this is actually the conversion of a traditional microscope into a scanner. But of course, the scanner that has been enhanced, yeah, with different algorithms, yeah, including artificial intelligence. Yeah. So by all this technology, yeah, algorithm and artificial intelligence, we can convert a microscope into a scanner, microscope scanner, with have a better speed, a much faster speed, and also a bigger deep zoom analysis because it is enhanced by the algorithm and also other artificial intelligence technology, and it can do a whole slide imaging. Sorry, this is not scale imaging, whole slide imaging, because the current technology, the traditional one, they only use one single slide. Yeah, one single slide, one spot. But by using the scanner, we can just scan the whole slide in a faster manner. And of course, with the enhancement in digital image processing, we can get a better, accurate data. So this is related to pathology. Yes.
Excuse me, Professor Auda, that we have 2 minutes remaining.
All right.
For the session.
All right. Thank you. 2 minutes. Yes. All right. So that is the first part. I would like also to present my second part of the talk, which is just briefly about what I have been doing in the last few years, which is the development of Indonesian biopsy database, both website and application based. So what we are trying to do here is actually to really curate the data for biodiversity-based research in Indonesia, which to now has not been really stored in terms of database. So what we are trying to do is the first one is INPEL, development of nature products library INPEL for drug discovery. This is the basic idea is how we collect all these nature products and then stored in the database, and the database linked to the repository data, the physical repository data. So the INPEL repository link database for biodiversity with known function, especially for drug discovery purposes. So we have two main objectives, the database and also the repository. And this is the role of INPEL, a window to Indonesian-based biodiversity research, a platform that links the virtual and physical repository of Indonesian biodiversity. So you can imagine even from a very single experiment, we can generate so much data, and the data need to be stored for further analysis and further study. So otherwise our data will not just go in vain. So this is the appearance of INPEL, and this is INPEL. This is another one is CITMED, Citizen Medicine, is a more popular database, which is based on Indonesian traditional medicine. So that's all my presentation. We understand that it takes a lot of effort, and of course we cannot do by ourselves. That's why we need cooperation and collaboration, and also institutionalization of the work, and later on the needs of national implementation. Last but not least, I would like to acknowledge some of my research groups and collaborators and funding from different sources. And thank you for your attention. Thank you.
Thank you very much to Professor Auda for the very interesting and insightful presentation. As it was presented by Professor Han, it was a very comprehensive lecture, and I think it may require more than 20 minutes to have a very deep lecture for such a very interesting topic. So, Professor Auda, we hope that it will be possible for us again as a lecturer and scientist from audiences or Universitas Terbuka, perhaps, to have further discussion with you by email or other means of communication.
Certainly, yeah, look forward.
Thank you. And some of the interesting note that we may highlight are the use of telemedicine in the modern era, which is very relevant with the philosophy of Society 5.0, in that such delivery of healthcare service is not bounded by physical distance, because the healthcare professional itself is using information and communication technologies for exchanges of valid information for diagnosis, treatment, and prevention of disease. And several important examples that is developed by Professor Auda and the Swiss German University is that the first is the telepathology microscope scanner technology, development for cancer detection, as well as other research such as development of Indonesian biodiversity database and development of natural products library. And Professor Auda, we will have a Q&A session at the end of the first session of plenary. So for all the audience, please prepare for the question in the Zoom chat box, and don't forget to put your identity in the question and to whom the question is asked for. And now we move on to the last lecture in the first plenary session. Is the lecture which will be delivered by Professor Shobha Ranganathan from Macquarie University, Australia, which is entitled Quantitative Biology for Society 5.0. But before the presentation by Professor Ranganathan, allow me to read the brief CV of Professor Ranganathan, as we may see in the main monitor now. So Professor Ranganathan is Australia's first chair in bioinformatics at Macquarie University. She has held research and academic positions in France, USA, India, Singapore, and Australia, and has been a consultant to industry. She served as the first elected Australian director of the International Society for Computational Biology, or ISCB, and the president of the Asia Pacific Bioinformatics Network from 2005 to 2016. Professor Shobha investigates molecular systems in silico to assign biological function and to develop clinical solutions for diseases. Her multidisciplinary research focuses on developing and applying innovative technologies to address current national and global biological challenges in human, animal, and plant health. She applies knowledge extraction from big data, functional integration, and machine learning to provide meaningful outcomes. Professor Shobha is a very passionate bioinformatics, biochemistry, and chemistry educator. And yeah, so to Professor Shobha Ranganathan, without further ado, you may start the 20-minute presentations now.
Thank you for the kind introduction, and I thank the organizers for giving me this opportunity. I'm not going to talk about my research. You can find my research in the publications, but what I'm going to talk about are how we can use this new term, quantitative biology, for Society 5.0. This was a topic that has been a challenge to me, because I could see that it's a length and breadth of what we can do in our society to prepare for the future. So, to get started, okay, we are going to have a very brief overview on Society 5.0 and quantitative biology, which is an absolutely new phrase that has come about, and I'm going to abbreviate it to QB because it's such a big mouthful. So we will look at what are the key areas for QB in Society 5.0, again abbreviated to S 5.0. But very importantly, in order to actually do something, we are going to actually ramp up our education and training, which then involves all the academics in the audience, because this is what they need to think about for the future. And a few examples where QB can make a difference and what are the outcomes that we can foresee, and a very brief summary of what I can do. So human evolution has focused on going from being a hunter-gatherer to being a farmer, to being an industrialist, and now we are all sitting at computers. So this is our evolution to date, and this has been summarized in Japan very nicely as the hunter-gatherer society, the agrarian society, the industrial society, and the information society. And these are the four possible steps that we can think about. It does not mean that we still don't carry out hunting or agriculture or man industries, and not all of us are in IT, but we need to build up this scenario because quantitative biology addresses everything. In Society 5.0, we believe that we will have enormous data stores, which is called big data. I'm sure Dr. Asif Khan explained to you how we can gather and store this big data and analyze it. And we also use a lot of information technology and artificial intelligence to process this big data and communicate it using the Internet of Things. In the final analysis, all these are geared towards better human life. But is it only human life? That is what I would like to explore. So what are these? The big data, the AI, and the IoT. Currently, we have big data on practically everything. As you know, Facebook and all the other internet resources, they have already collected huge amounts of data. This data is used by people who forecast disease, such as COVID, or financial management, analysis and research, or by politicians who need our votes. They are also looking at this data. But at the same time, it has actually benefited research in the areas of biomedical science. As the application to cancer showed, we need the data first before we can do anything in the previous talk. And we also use this data now for biodiversity management. How can we save the species that are existing in our planet? How can we mine this data, and how can we use it to benefit something, either us or the plants and the animals around us, or save the environment by degrading all the waste materials that we are actually generating on a daily basis. So what is artificial intelligence? It is trying to make programs and software that mimic our own neural networks, our brain, which is the best processor. But when we have larger and larger amounts of data, a brain alone cannot actually process it. So they have developed machine learning, speech analysis, audio recognition, image recognition, which is used, of course, in the telemedicine application that you just heard, machine vision, also to provide vision to people who cannot see. That is also done in this way. We can also process natural language. This is how our supermarkets actually sell us products that we are constantly buying. As you can see, they are using expert systems They can plan and optimize delivery of materials, and we can also generate robotics. So AI is used in many different ways. And we use the internet to communicate, to either collect the data from different resources and store it, or process it elsewhere, as well as disseminate this information to the public and to analysts who can actually deliver the results. So how does quantitative biology come into the picture? So long we have been talking about bioinformatics, but while I was in Singapore, way back in early 2000s, we actually came up with an idea that we need to think about life science informatics, where we put in ecology, biodiversity on the one side, genomic data from all species on the other side, as well as medical data, and put all this together, and we called it life science informatics. This seems to have got a new avatar now. It's called quantitative biology. Very simply, we are using mathematics to understand biological matters. That is, in the words of Richard Feynman, Nobel laureate, he said people who wish to analyze nature without using mathematics must settle for a reduced understanding. Therefore, in order to get the full information, we need mathematics, statistics, and computational techniques to study life and living organisms. From when we have sufficient data and methods, we can develop predictive models based on the fundamental principles governing living systems, which is then called quantitative biology. And it also encompasses systems biology, bioinformatics, programming languages, statistical models, computational NGS, and so on. It involves practically a lot of different fields and has applications or in all aspects of biology, including human biology, which is health. Therefore, it is a more comprehensive term, and I suggest we start looking at it very seriously, because the future is going to require this knowledge. From a review article published way back in the 80s, I found that QB was actually a very old term. It was actually invented, I think, in 1950. But it has not been very popular till now, because only now we have the computational power and the internet to gather the data that we can use in biology. So anything in biology can be connected, and we can carry out data analytics, data science, and machine learning only if we have the data. And areas where QB will be applied, it's natural resource management, such as the biodiversity database that you just saw, environmental monitoring and restoration, especially if we have floods or hurricanes or tropical storms, earthquakes. How can we monitor this? How can we revive the earth to where it was after a natural disaster? Whether a natural or a man-made disaster, we need to then look at how to restore the place. We can also use it for the conventional data, genomics and proteomics, which is the molecular aspect of bioinformatics that we are very familiar with. We can then use this knowledge at the genomic and proteomic level to understand the phenotype and map it to different areas, which types of rice would grow under global warming with less water as the world gets more dehydrated, and so on. So that is being currently carried out right now. How can we manage invasive species? I am actually working in this area, and I'll briefly touch on it, because with global warming, we expect that insects that were tropical are going to invade the whole of Australia, and we are preparing for it. disease transmission in plants and animals. This is very critical, especially in view of all the pandemics that we've had so far, because many of the diseases are zoonotic in nature and somehow they find their way to human beings. Then we can regulate genetically modified organisms. This is going to happen because a long time ago they said no to organ transplants. Now that is commonplace. They said no to open heart surgery. Now that is commonplace. So please expect in the next 20 years, we will definitely have carefully genetically modified organisms available, which will then be able to feed the world's population. We can apply it to ecological forecasting, monitor animal behavior, and apply it to neuroscience, which is actually the foundation of artificial intelligence. Now, when we start putting these things together, we know that sometimes there is a little bit that we know, and we are very happy about it. And we already know that we don't know some of the things, which is in red, but there is a huge unknown out there of things that we did not even realize, that we have absolutely no idea about. So please prepare yourselves to go into the unknown and explore this area. For this, we need students who know the biology, but who can actually do the analysis of biological data. So we need biology and computational courses together. So far, biology has been for students who like to work with biological samples, go and do field trips, collect organisms, collect species, and map them. But that is no longer enough. Biologists will need to learn programming languages and tools, and biological topics are including now a huge range of subjects which require statistical analysis. And once we have the tools of the biological topics and the data accruing from them and the knowledge of statistical analysis, mathematical models can be developed to predict for preemptive solutions. And many of these solutions come from AI, artificial intelligence, when we train the model based on the data that is available to us. Of course, AI is a completely different topic, so I'm not going to spend a lot of time on it, but we do know that we can apply these methods to many aspects. And the first one that comes to mind is community ecology of disease. And many of the diseases that were known earlier were actually analyzed in this way to understand transmission across species barriers. They include Ebola, hantavirus, bubonic plague, Lyme disease, West Nile virus, rinderpest, and canine distemper. And currently we can include all the pandemic flus, H1N1, SARS-CoV-2, etc., because they have affected our ecology in a way that we can't even evaluate at the moment because the disease is still ongoing. We have just come out of lockdown in Sydney, but we can only go within Sydney. We can't even travel outside the city. So that is the limitation that we are facing. We are all still working from home because only 30% of people can be at the university at any one time. So quantitative theoretical frameworks are required for data collection, how to get the data which is meaningful, estimating transmission rates, and to understand disease patterns. Such models will help us to control disease outbreaks, maybe by forecasting that there would be this kind of disease, or when the disease manifests, to understand how we can control it by vaccinating, culling certain creatures which are actually the hotbeds for transmission, or treating particular reservoir species. So this is how we can actually tackle this problem. We can also look at population size, inbreeding, genetic variation of various organisms. And particularly, we are working with a group of biologists working on the Queensland fruit fly. A similar fly is also known in Indonesia, and many of the biologists were expertise in sterile insect technology or in lure manufacture. And now we are working on both these. How can we get more chemicals that will attract these flies? How can we circumvent SIG+? And we are even looking at olfaction in these species to understand what it is that attracts them to specific fruits, which they then demolish. So we need genetic variations, and populations will also not be able to respond to natural or artificial selection based on this genetic variation. So we want to understand how genetic variation affects evolutionary biology and can be applied to animal and plant breeding and also conservation of rare species. So modeling the evolution of correlated omic sequences is what is currently being carried out to understand the connection between genotype and phenotype. A very long time ago, there were studies on the pea plants, but those traits are actually visible. But human beings, on the other hand, are very complex organisms, and the variation of complex traits is not so easily managed. And we need to do quantitative trait locus analysis to understand how the genomic changes across multiple chromosomes will then affect a phenotypic change in the organism. And perhaps we ourselves are being evolutionarily selected to work with only our thumbs on the mobile phone. I don't know, maybe that will be the next generation. And maybe you will find out which of these genes actually are able to help us to do that faster. So I leave that to you. And genotyping individuals can lead us to understanding disease manifestation, especially in the case of inherited diseases, because these can therefore be identified in the stage of the fetus, and perhaps there can be some solution using genetic engineering, gene modifications, and so on, using vectors to prevent such terrible diseases. So we can look at ecosystems and ecology on a very large scale. The whole country, especially a large country like Indonesia, can use these maps and data gathering exercises to understand the effects of land cover and usage, carbon flow in ocean and atmospheric systems, and the effect of climate change on species, as well as how to protect our own ecosystems. The mathematical theory will perhaps one day help us to solve the global scale ecological problems that we are being confronted with today. Species diversity can also be predicted from biochemical kinetics of metabolism. And I think Dr. Auda will be using something like this in the future from all his databases on biodiversity. This would then lead to a thermodynamic kind of model for the regulation of species diversity and to organize ecological communities. This will then hopefully preserve some of the species, which will then continue on and provide the background for biodiversity in the future. Neuroscience is going to be really very much affected by quantitative biology because it is the network of neurons that actually led to our understanding of neural networks and deep learning, etc. They were all based on this. And I point out here that Hodgkin and Huxley studied the action potential in the squid giant axon, not in the humans. And this led us to understand how this propagation, signal propagation, can be mathematically represented and led to their Nobel Prize. So it is the combination of mathematics, a biological system in a marine organism that actually led us to artificial intelligence currently. So theoretical approaches in neuroscience are necessary to make connections between channels, to spiking in signals, or from neuronal connectivity to behavior, because we can actually modulate human behavior by inducing favorable or positive signals in the brain, which is very important in times of COVID, because we are facing isolation and we are facing home-based work. We are not able to communicate with our colleagues, nor have a cup of coffee together, and no te-tare, etc., no time off. And therefore, we are all getting very, very isolated and moody. Maybe we need to actually instigate some positive responses to do this. So we need dynamical systems, information theory, and pattern formation to understand our own nervous system, which we can then inform new and better artificial intelligence approaches for data gathering.
Excuse me.
Yes.
Excuse me, Professor. I think we have around 1 or 2 minutes left.
Done. We are almost there. Yes. Our application will probably be to personalized medicine, because we need multiple layers of data to be gathered, almost like a GIS system for a human being. Please read this paper and you will see a lot more about it. And we actually have used data from Michael Snyder in Stanford at the DNA, RNA, etc. level to make a map that looks like a metro map, which links many of the biochemical processing, which can then be used to actually gather information to treat a person properly. So whole genome sequencing to identify variants is very much on the cards. And from 100 individuals, they could actually identify a novel adenylate cyclase mutation, which is only present in 8 people so far. However, the disease does not have a drug or treatment option yet. It's only brand new, and therefore there is chance for research there to help these patients. The good news story for today is that there is a nucleoside analog that has now been almost approved for treatment against COVID. This was known since 2018 against multiple coronaviruses, and it is going to save a lot of people who might get infected by COVID. And we see that we will be collecting this kind of omic data before the baby is born, from the patients all the way till a person dies, what they call womb to tomb, to actually understand how to do this. So we need quantitative biologists who can do all these numerous things, because they are familiar with complex statistical procedures to extract specific data. Terima kasih, and I'm ready for questions. I think this is the last session, and therefore we are ready to actually talk and answer your questions.
Yes, thank you very much, Professor Shobha Ranganathan, for the very interesting and comprehensive lecture. And some of the note that we may highlight are the importance of the quantitative biology in natural is that it's using mathematics, statistics, and computational biology to study life and living organism, as well as developing predictive models based on fundamental principles governing living systems. An example of the study and application of the quantitative biology is the community ecology of disease such as Ebola, Lyme disease, West Nile virus, etc., as well as the study of population size, inbreeding, and genetic variation. modeling the evolution of correlated omic sequences, and quantitative ecology science and large-scale ecology. So, as the lecture from Professor Ranganathan is finished, now we enter the first plenary discussion session 1. And for all the chat that we've gathered, we will select several of those from the audience, and we apologize that not all the questions will be delivered to the speaker. And some information to all the speakers. So our audience is kind of like a broad audience. There are some students of Faculty of Science and Technology. There are also some scientists or lecturer from Universitas Terbuka as well, and also from other institutions as well. So perhaps the IT team can highlight or spotlight the first question. Okay, so this is the question. 2 questions to Professor Asif Khan. The first one is from Bapak Joko Isdianto from the Faculty of Social Science and Government Science. The first one is how are your daily efforts to keep the data still in original data, no malware attack or virus, and how to synchronize the data from all over the world daily? Yeah, you may answer the first question first. Thank you, Professor.
Thank you. Correct. So thank you for the question to Joko Istianto. So there are 2 parts to this. One is how are your daily efforts to keep the data still in original data? Okay, so of course we have our, the usual suspects. Your firewall is going to be there. Your passwords. Nowadays you have 2-factor authentication. And you can do blockchain and all that too. But I think more importantly, if it's really sensitive data, encryption I think would be a key here. But of course, encryption also has a cost. So depending on how important that data is, there are various options one could deploy in order to protect the sanctity of that data. All right, so these are some of the usual ones. I think blockchain and encryption. Blockchain may be a little high end. Encryption is actually already there. Or WhatsApp and messages are already encrypted. So that's an example. The other question was synchronize the data from all over the world. So there are again 2 ways to look at it. The basic low-level option, if you're using Linux, rsync would be one way to kind of synchronize data from different parts of the world. If you have servers in different parts, you could use rsync. But you could also, for more sophisticated solutions, you could use some of these distributed file systems. So Hadoop, for example, is one of those. Google has its own. So there are a number of distributed file systems that one could use that would synchronize automatically for you and also kind of help you with the integrity of that data. So I hope that answered the question.
Okay. So for the second question from Asep Sunandar Sumantri to Professor Khan, to the IT team. Yes. How biological data warehousing and bioinformatics are generally known as an application or algorithm used to interpret complex biological data into biological information that is easy to understand for people to apply in their lives.
All right. So that question, actually, I didn't understand.
Okay. Yeah.
Yeah.
Perhaps.
So,
Mm-hmm. Perhaps we can move on to the next question to the IT team.
Yeah.
Okay. Okay. Perhaps we will ask the question from Fanny Widodo, which is may more of interest. So it is so interesting that what you presented to us about bioinformatics for Society 5.0. I am a student who have interest to do some research in data mining and algorithm. Would you mind to mention some of open data source that we can utilize to do some research about this bioinformatics study?
Right. Actually, for this, there are just so many of them out there that one could use. The first thing, maybe the first place to go would be just to go to NCBI. Google for NCBI. There are so many databases that provide data for free. All right. So at no cost, you could easily download, and they even provide tutorials and a lot of other things that could help you, even tools. So NCBI would be the first place I would recommend. But again, depending on what kind of data you're looking for, you could search for what you call an NAR database issue, nucleic acid research database issue. This is actually a journal that publishes publishes annually an issue on biological databases. So you could go there, and there will be a list of databases that are available for biological data. So that's a great place to start. You can get a comprehensive survey of what's available. NAR database issue, every year there's an update. So that's a great place to go. Of course, there's another journal called Database that would also have. So NAR is not very comprehensive. It's comprehensive, but not, of course, complete. I think Google search is a great place to start, biological databases, and I'm sure you'll find many, but I would recommend highly to go to NCBI, then to go to this NAR, database issue, and also check out the database journal. These are some of the few starting points.
Yes, thank you very much, Professor Han. And then perhaps to the IT team, we can move on to the question for Professor Auda. Yes. First from FST's lecturer, Muhammad Radiansyah from Food Technology. He has a question. In terms of Society 5.0, can we use telemedicine to create a more integrated medical data of the population, especially in Indonesia, where personal medical data is less easily accessed?
Okay, thank you very much this is a very nice and also challenging question, because we are all also facing the same issue about accessibility of data. That's why we have to work closely with hospitals, because there are ethical clearances that we should perform in terms of data accessibility. So without their permission, we will not be able to do this. Yes, so that's why in our early stage of work, we start with collaborating with hospitals. That is the must, because at the end of the day, the doctors, the medical healthcare will the parties that will use the data anyway. So we have to work with them closely. Otherwise, we will not be able to get any data from them. So that's why the first step. But the possibility is there. In fact, we've been working with some hospitals, such as Rumah Sakit Fatmawati and also Hasan Sadikin Bandung, some of the major hospitals, including RSCM. The things that we just have to communicate with them and engage them at the very early stage of our research. Thank you.
Thank you, Professor Auda. Then we move on to the next question from Joko Isdianto from the Faculty of Law, Social and Government Science from the Universitas Terbuka. So the question is, how do you make a standard measurement that the telemedicine is effective or not, success or not, and having an accurate data or not?
Right. Okay. Thank you very much. So first and foremost, when we start developing something, we have to go to process what's so-called validation. So without validation, our data, any data will not be, it's not about only accurate or not, but it is accepted or not by the people. So in order to do that, we have to again engage them. For example, in terms of telepathology, we will not be able to get validated data without their involvement. So we have to, for example, test it, developing some algorithms, methods, and then we apply to the real objects, the real subjects, the real samples. And then later on, we ask them to validate whether our data is correct or not. So we'll get a percentage of how much percent, how many percent that our data is valid or not. Then hopefully from there, that will be a very good starting point that our data is accurate. If let's say the medical provider said, yes, I have validated, and we got certain percentage of the validation data. So that's why we have to set up standards on parameters, what parameters that need to be evaluated and so on.
Okay, thank you very much, Professor Auda. And I think we can move on to the questions for Professor Shoba Ranganathan. Again, yeah, and question again from Bapak Joko Isdianto from the Faculty of Law, Social and Government Science, Universitas Terbuka. So his question is about what are the main barriers in using quantitative biology, and how do you make a standard measurement that the quantitative biology is effective or not, success or not, and having an accurate data or not? I think it's kind of like a bit similar with the question to Professor Auda previously. So yeah.
Yes, I think maybe both of us should answer the question together. But what I can see is the main barriers in using quantitative biology is that people who undertake biological science study or ecology study or biomedical sciences, they don't actually enforce mathematics, statistics, and programming, artificial intelligence methods at a high enough level to actually undertake quantitative biology. So perhaps it's not suitable for all undergraduate students, but at the master's level, if somebody is able to take the mathematical aspects from biology or take mathematicians and then inject them with biology, then we can actually get a good quorum of people who can use QB. The success or the effectiveness will only be there when we have enough people to make these studies and to actually carry out the analysis. But definitely having a multi-omic study these days has actually shown that there are cures for several cancers that are currently being used. And even for personalized medicine, recently iLife had a Drosophila model of adenoid cystic carcinoma, by which patients were given specific medication based on their phenotype by developing these in insect models, and that has been proven successful. There are new applications and new success stories are coming out. But as always in human evolution, 10 times we fail, maybe once we will succeed. So that is how we have to try many things before we can succeed. And I suggest Joko to actually take up research and provide us some solutions so we can see how successful he is in the future.
Thank you, Professor Shobha. And we move on to the next question from Bapak Suparman.
What regulation is needed to avoid negative effects of biological engineering? Well, we don't know what regulation is required. Definitely anything that is lethal or toxic will not be permitted. However, we do know that we had this BT cotton, this Bacillus thuringiensis cotton, which has then not affected by wasps and was being grown all over the world. Well, welcome to the real world of biology. The wasps have developed mutations that permit them to go and eat the BT cotton. So now biologists are back looking at the phenotypic nature. We are just writing a project proposal to study what will be the nature, what kind of metabolism is involved in metabolizing the toxins to understand how to overcome that problem. Definitely, we need legislation on biological engineering, but genetic engineering at a very human level is still a very long way away, because that is not permitted in most societies, most religions, and most legal systems. There was only one example of genetic engineering in human beings, but something like gene therapy, which actually introduces a working copy of a gene into a person who has 2 recessive copies and is suffering from an incurable disease, is something that we can think about as a way to save that person's life and provide a good outcome. So if such gene therapy techniques are permitted, then perhaps there is a solution to that patient's disease. So the legislation is currently capable of permitting such specific cases. So I think maybe we don't want to over-engineer legislation as well and also cause a lot of reaction and resistance. We need to see how things are. If things work in model organisms, if things work in vivo, then in vitro, then maybe and under mouse or some other model organisms that can be used for the future for human beings. We will have to try. Not everything works, but something will work.
Thank you, Professor Shobha. And to the IT team, okay, there is a new question from the YouTube channel from
Yes.
Ibu Pepi. She's a lecturer from the agribusiness study program. So what is the important keywords for developing countries to adapt to qualitative biology? Well,
it's actually quantitative
yes,
biology.
Yeah.
So the problem is that in the early times, a long time ago, there wasn't even science. There was only study. And everybody learned everything. They learned poetry, they learned literature, they learned history, they learned a little bit of science. They learned also how to protect themselves from invaders. But now what we have done, we have bifurcated all the studies into different compartments. And because of that, people are therefore choosing soft options. People who learn bioinformatics are actually learning elements of programming, some statistics and mathematics and regression. So I see that bioinformatics coupled with this newly developing data science model from computer science would then lead to quantitative biology. Perhaps in this generation, even in developing countries, we have sufficient people to form teams, work together, work on a joint project and solve the problem. And then you can educate the next generation by specifically targeting these people. You will see that many universities in Australia are no longer offering masters in bioinformatics. They are offering masters in quantitative biology and bioinformatics. So they are slowly seeing the big picture, and we need to take others there. Okay? So that is my solution. It is a shortcut solution, but I think it will work. And that is what AP Bionet has been trying to do. Take the bioinformatics to the people who need it, the biologists. The biologists, the plant scientists, the medical scientists, the pathologists, because then that subject would have an application, a value, and will give back to the community.
Thank you, Professor Shobha. And yeah, as you mentioned that it is you encourage, especially for biologists, to be able to bravely pursue or having an endeavor in in a quantitative way of science. I mean, because generally as a biologist myself, I mean, I take this bachelor and master degree in biology. It's a bit challenging for us to, you know, really dig deep into a new frontier of new field of science. And yeah, but thank you very much. But perhaps you can have any, I don't know, kind of like
I have
other
a last sentence to say. I'm not a biologist. I'm not a computer scientist. I trained as a chemist, and my PhD was in quantum chemistry. I learned the programming and I applied it to chemistry. And all through my research, I have worked with biologists, veterinary scientists, agricultural scientists. Now I'm working with entomologists. I tried to learn the biology and I learned the application. We taught ourselves artificial intelligence. We read, we ask questions, and we learn. Human beings are capable of this. The brain is plastic. Develop your neural networks. You can do it. Just be confident and you can do it. We are all there to help you.
Thank you very much, Professor Shobha, for the very kind words of encouragement to me, myself, and as well as other audiences, for maybe a biology study program student or other scientists from biology, to always have the challenge to have a future endeavor in other parts of quantitative biology as well.
I think Asif is heading in the right direction because he's taking AP Bionet from bioinformatics to data science. And now he will land us somewhere else, I'm sure. Okay.
Next will be UT, bro.
Okay, then. To the IT team, perhaps we have some question from YouTube channel or the other selected question from the Zoom chat, or hello, the IT team, perhaps can give a spotlight.
Okay. Perhaps Mr. Fauzi, I'm not sure if it's Dr. Fauzi or Mr. Fauzi, but please collect all the chat messages and email it to us.
Yes.
And we can maybe write the response and you can post it on your website.
Yes, for sure, for sure. We will organize all the questions.
Because there are many interesting questions, but I think time is against us.
Yes, we agree with you. And yeah, as always, we hope that we can still contact all of the speakers for further scientific discussion and perhaps, arrange some collaborations, etc.
Yes, and we also know many people in Asia Pacific who can be partners to people who need collaboration or somebody to just discuss their ideas with. For example, Dr. Kolis would do very well to work with Sarinder Kaur and Soraya Malik at University of Malaya because they are working on similar things. They are working with image analysis. They are working with using pathological samples to screen for types of breast cancer, all kinds of strange things that they are doing. And I usually review the thesis, so I understand a little bit, not too much. So maybe an expert like Dr. Collis would profit by that. But I must suggest that Indonesia...
I'm a student, so I'm not the expert, I'm a student. But
I would like to recommend.
Working with Dr. Sarinder Kaur as well. I know her very well. Because when the first bioinformatics lab was established in Malaya, I was the first student, and Dr. Kaur was the first undergraduate students work in the lab.
So, but very importantly, we are missing something here. By only taking a scan of the pathological sample, we are missing the genomic and proteomic content.
Correct.
So we need to have biobanks to store the nature of the sample.
Right.
Because that is something you cannot replicate on a scan. We need the stains. We need the stains for the different organelles to see where the cancer is, and we also need the tissue itself to be saved.
Right.
To be stored under, minus 80 or something, minus 120, so that we can retrieve the sample for omic analysis, for variants, to see if this is a genetic disease. Both these things are required, both, not just one. This is very handy, it's quick for a Finnish physician to see when he's far away and then recommend, no, this does not look like it's very serious, so it might only be benign, that kind of thing, they can make a decision. But the real truth of the matter will come from doing genetic analysis.
Very true, Prof. Very true. So very true. And I'm doing it for the extract library. So we work on metabolomic right now as well. So we collect. Yeah, but when I asked them about genomics work, they said it's too fancy.
Here today, yesterday, I was on a collaborators call for the ProCan project, Children's Medical Research Institute. They have a proteomics for cancer project, and they are going to give clinicians proteomics data in 48 hours, high throughput proteomic data.
Hopefully, we are going to that direction, Prof. Soba, because I also propose proteomics and genomics as well. But as you know, Indonesia is always left behind, sorry to say, maybe 2 decades at least when it comes to all these omics. Well, people already talk about single cell omics. We are still talking about second generation genomic sequencing.
So it will all change because nanopore is going to get much better. So you will be able to do it for a lot less, and you will be able to do very quick analysis. I think that the future is very bright, It doesn't matter where you are. Please apply for a Bill and Melinda Gates Foundation. I hope the foundation is not divorced, so they can actually give you the money. So please apply. And there is Human Frontier Science grants, things like that. So I'm sure there will be funding to do this. By the way, there is also UNESCO Chair of Biodiversity Informatics. I was the first one in the world, but they didn't give us any money, but they will definitely give money to developing countries. So please apply to them.
Yes. Thank you very much to Professor Shoba for the very interesting discussion that we have, to Professor Han, to Professor Auda. And I think because the time is up now, so we are very sorry that we cannot continue this live discussion, the Zoom. So yeah.
Yeah, I am waiting for the second session. I will be here. Thank you.
Thank you very much, Professor Shoba. So now with the conclusion of the Q&A session, those conclude this first plenary session. And to the three speakers, Professor Han, Professor Auda, and Professor Ranganathan, please remain in this live session because we will present a token of appreciation from the Dean of the Faculty Science and Technology, Universitas Terbuka, to all of you. First to Professor Muhammad Asif Khan, the certificate, and perhaps to the Dean of the Universitas Terbuka can give some, yes. To Ibu Dr. Subakti Nurmawati.
Okay, thank you. Thank you. Three of you have presented very interesting for us. Honorable Mr. Dr. Muhammad Asif Khan, we express our deepest gratitude by giving you a certificate. Hopefully it will be well received.
Thank you very much. My pleasure.
Okay. Yes. And then the second speaker, our Honorable Mr. Hollis Abdurrahim Audah, PhD. Thank you for taking part in this webinar. As our appreciation, we present a certificate for you.
Thank you very much, Dean Dr. Subakti. Thank you. Yeah.
Yes. And the third, our Honorable Mrs. Professor Soba Raganathan. We thank you very much for being a guest speaker at our seminar today. We present a certificate for you. Hope it's well received.
Thank you very much. I'm very grateful, and I enjoy the fact that Indonesia is taking the trouble to take its people to Society 5.0, which is already very futuristic. So I see that the world is very bright for you, and everything will happen when the people want to do it. So
thank you very much.
It will go forward. Thank you.
Thank you very much to Ibu Dr. Subakti Nurmawati and all the speakers. And yeah, we can give a big round of virtual applause in the Zoom menu and maybe in the camera to the invited speakers for the very interesting and insightful, inspiring presentation. And as always, we hope that we as a committee and audience can still have a further scientific discussion by other means of communication, such email, etc., to all the speakers. And next, to all the participants, please turn the video on and make sure that all of us is using the same official virtual background provided by the committee, and because we will have a photo session. Yes, to the IT team, are we ready to document the session? Okay, IT team.
Okay.
Yes, yeah,
Ready?
comments on yours, yeah.
3, 2, 1.
And perhaps we can wave to the camera, to the variety of the...
3, 2, 1. The last. 3, 2, 1. Okay, Mr. Fauzi.
Thank you to the IT team. Thank you very much. And that concludes the first plenary session. Yeah, once again, thank you very much to all the three speakers, Professor Han, Professor Auda, and Professor Ranganathan for the very important presentation. And we wish you very good health And thank you as well for all the audiences for the active participations during this plenary session. And I apologize as a moderator for any mistakes that I've made in guiding this first plenary session. Goodbye for now, and I will give this session back to the MC, Ibu Fenty Fitriani Nurunisa. Goodbye.
Okay, thank you very much, Mr. Fauzi, Mr. Zuhairia. Once again, we would like to thank Professor Khan, Professor Auda, and Professor Rangganathan, and of course, Mr. Zuhairi for such an interesting sharing session about bioinformatics, telemedicine, and QB. And I'm sure that all of you also enjoy that inspiring session during the first plenary session. So, ladies and gentlemen, now let us move to the second plenary session. And it will be moderated by Dr. Anak Agung Made Sastrawan Putra, MA EDD. But first, let me introduce Dr. Putra by reading his CV briefly. Dr. Putra graduated his undergraduate at IPB University in 1984. He continued his education at University of Victoria, Canada, and earned a Master of Art in Education in 1993. In 2013, he earned his doctoral at Florida State University in USA. And right now, he is a lecturer at Agribusiness Study Program, Universitas Terbuka. So without any further ado, Dr. Putra, you may start the second session of the plenary. Would you mind to turn on the microphone? Yeah, thank you.
Thank you, Ms. Nurunisa. Good morning, ladies and gentlemen. Maybe good night for Dr. Haider in USA, because in Michigan now is past midnight. Ladies and gentlemen, now it's time for us to join the second plenary session. In this session, we will follow the lecturers from three honorable speakers from three different countries. The first speaker is Professor Dr. Hafizan bin Juair from University Sultan Zainal Abidin, Kuala Terengganu, Malaysia, our neighbor. And then the second one is Dr. Owaisim Haider from Central Michigan University in the USA, in Mount Pleasant, exactly, the city, but now at midnight over there. And then the third is Dr. Enik Juliana from Universitas Terbuka, or the Open University of Indonesia. I would like to greet our three speakers. Good morning, Professor Juair. Are you already there?
Yeah, thank you. Good morning, Dr. Putra.
Thank you. Good morning, Professor Juhair. And then I heard from Dr. Haider in Michigan, because now it's just past midnight. We cannot join us right now, but we hope in discussion session he can join us. But Dr. Haider has already sent his recorded lecture. And then the third is Dr. Enik Juliana. Good morning, Dr. Juliana.
Morning, Pak Agung.
Good morning. Okay. Now we start from the first presentation from the first lecturer, from Dr. Haider. Before that, I want to inform you that you can write your question during the session, and then will be read during the discussion session. Now, we try to read the CV of Professor Dr. Hafizan bin Juhair. Actually, Professor Juhair has a very long academic record, I read. But let's follow the short CV. Professor Dr. Hafizan bin Juhair is the professor of the University Sultan Zainal Abidin in Kuala Terengganu, Malaysia. He is a deputy of Vice Chancellor Research and Innovation in University Sultan Zainal Abidin. And also he has served as a director of East Coast Environmental Research Institute in University Sultan Zainal Abidin. He completed his PhD at University Malaya, Kuala Lumpur, Malaysia, and his research interests are in the chemometrics or environmetrics, environmental forensics, analytical chemistry, data mining techniques, environmental modeling, and quality engineering atau Six Sigma. He has many scientific works in journals, proceedings, and media writings, and his citation more than 1,084 in Scopus and 2,192 from Google Scholar citations. He has received many awards from his research and innovation, such as Citation Award, International Grant Award, and Research and Innovation Award by Research and Innovation Award in 2019 by UniSZA. Award from various competitions, such as Industrial Technology Exhibition for his smart measurements kit or Smart Me Kit, and Maqasid Sharia Quality of Life Assessment Application, EMSQOL, and Waste Trap from Research and Innovation Week in 2019. He has done various important roles in the organization of many local and international bioinformatics conferences, meetings, and workshops. Now we welcome Professor Bin Juhair to present your lecture. Thank you.
Yeah, thank you, Dr. Fusra. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning to everybody. It is my pleasure to join all of you at this first international seminar of science and technology for society's development, and with the theme Science and Technology for Society 5.0. Firstly, I would like to thanks to committee members of first ISST 2021 for the invitation to me as a plenary lecturer. Today, actually, I would like to share my little experience of my research in environmental big data analytics to gather quantitative evidence to defense the policy of environmental criminal court cases through the chemometric technique in environmental forensic. Actually, in my quite different presentation from the other three previous speakers, okay, actually I will share step-by-step approaches how to apply in application of statistical multivariate technique coupled with artificial intelligence. Actually, what have been discussed previously, okay, by our three speakers. Okay, I share my screen first. So, excuse me, I couldn't share my PowerPoint. Okay. Okay, my title of presentation is Role of Chemometric in Environmental Forensics, Water Pollution Perspective. What is chemometric? Actually, chemometric is the application of the chemometric is a branch of analytical chemistry. In general, it's involved the application of statistical data analysis, multivariate technique, data mining, and artificial intelligence, okay, to solve the environmental problem, to interpret chemical data. Okay, actually, the early development of development went hand in hand with the development of scientific computing and primarily involved in material statistical method for the analysis of analytical chemistry. Okay, actually, early chemometricians were likely to be Fortran programmer using mainframes and statistical libraries of subroutine. Earliest applications were primarily on analytical chemicals data set, often fairly simple in nature. For example, a high-performance liquid chromatography, the cluster of 2 of 3 peak of the set ultraviolet and visible mixture spectra. Actually, when we do the lab analysis in a chemistry lab or biological lab, we usually using this equipment, and we can the result in the form of spectrums. And modern chemistry technique is the combination intelligent prediction models such as artificial neural network, positology, etc. Actually already explained in our previous presentation, our previous speakers. Okay, the role of chemometrics to defend the claim of water pollution incident in form of numerical evidence. Okay, to measure the variation of the possible pollutant physical of which significantly occurs in a water body from the suspected spatial sources, to provide pattern recognition evidence of the contaminated water in regard to physical substances from the contaminated area and the possible source of contamination. Actually, when we do the field samplings, and then we bring all the water sample or the polluted sample to the lab, we do the analysis, the laboratory analysis, then the analysis will give us the quantitative data. And then we do the statistical analysis, and we do the pattern matching to confirm that, and then do the tracing back what the possible source of pollution. Okay, and one of the first and most publicized successful story in chemistry is pattern recognition. Actually, the pattern recognition, and we need to confirm, okay, from the polluted sample, and based on the inventory provided by local authority, then we can go direct to the points of pollution, such as industrial. Let's say factory A, then we take direct sample from the discharge point, okay, from the factory, then we bring back to the sample to the lab and do the analysis, and we compare from the polluted river water sample. Okay, is it statistical? We need to answer, is it statistical different or statistical significant different from the both samples? If statistical significant different, so the possibilities, the contaminated discharge from the factory A, okay, maybe we need to further further investigation. The application of environmental chemistry to the law enforcement. What is the environmental forensics? Okay, actually, the environmental forensics is the application of environmental chemistry to law enforcement or the failure of product or processes. The application of defensible scientific method to address questions related to release histories and sources of contamination in the environment. Okay, many different analytical methods may be used to reveal what chemical changes occur during an incident, and so help reconstruct the sequence of events. This is what I said just now. We tracing back the source of pollution from the contaminated river water sample or any contaminated water samples. Okay, unique among the chemical science in that its research practice and presentation must meet the need of both the scientific and the legal communities. As such, forensic chemistry research is applied and derivative by nature and design, and it emphasizes methodology and validation. Okay, what the relationship between the society 10.0 and environmental issues with the environmental issue? Okay, based on the Sustainable Development Goal, okay, it's related to SDG number 13, 14, and 15, which is climate change, life below water, and life on land. Okay, society 5.0 and the environmental issues. Okay, actually the growth of the economy will introduce more new industry and new pollutant to our environment. Okay, then the increase of environmental issues will increase, especially in industrial sector, which is usually produce so much untreated discharge. Okay, to reduce the water treatment cost in reducing the water treatment cost, and it will give it will rise up the impact of the social issue, okay, due to the environmental pollution. Okay, then actually in environmental forensic, we only focus on the environmental justice need to be proper and link based on the environmental law. Okay, nowadays, due to increased concern in the water pollution problem, worldwide rapid water quality assessment was conducted. Beside the advanced technology in river water quality monitoring, the telemetry station coupled with IoT, where the online river water quality monitoring system were developed. As a result, abundance of cycling data. Okay, in this case study, in this presentation, I will show step by step the combination how we combine the primary data with the secondary data, with abundance of secondary data. Okay, which of the secondary data was able to be, however, the data were inappropriately handled because most of our research, actually in environmental science, we are not a mathematician. Okay, as a chemist, for me, this is we need expert in chemistry. We need expert in chemistry to clearly know, to clearly understand how the data, how to do the data analysis, and the most important thing, okay, how to interpret the data from the result given by the analysis. Okay. To use appropriate data analysis tool need to be considered the modern chemical technique as one of the powerful tools provide the scientists to solve or minimize the environmental problem. It is involved big data analytics, cloud computing together, and determine tremendous and complex data relationship. Okay, because in chemistry, in environmental chemistry, it involves complex relationship, okay, complex chemical reaction. Okay, in this presentation, I bring a case study of the Kuantan River Basin. Okay, it was carried out to make a clear understanding of the chemometric method in environmental forensic to trace back the source of pollution. Okay, actually, Kuantan River Basin located in the Pahang state. Okay, part of in the east coast part of Malaysia. Okay, and basically the river basin dominated by agriculture activity as a main economics activities. Okay, you can see, okay, oil palm, okay, 57,000 to 28 acres, and the rubber 10,000 acres, and fruit 10,000 acres. Okay, and the forest dominated 46%. Okay, in the river basin. Okay. Okay, this is the whole objective of the case study. Okay, number one, to develop the baseline study on database for the Kuantan River water quality, and second objective, to classify the spatial water quality pattern which may occur within the river basin, and the third, to determine the significant spatial variation of water quality parameters. Okay, the water quality shows significant. Is it the water quality show the significant changes from upstream to the downstream of the river basin? And number four, to identify the most possible sources of contamination in the river system, and number five, to estimate the source apportionment of the possible source of contamination. Okay, actually it involves the big data analytics, multivariate techniques, and coupled with the artificial intelligence, namely artificial neural network. Okay, this is the study area. Okay, in this study we consider 12 water monitoring station from upstream to downstream. Okay, we can see S1, S2, S3 until S12, and S1, S2, S3 located at the upstream of the river basin, and S9 until S12 are located at the downstream of the river basin. Okay, we try to investigate using the multivariate analysis to determine is it called the spatial water quality pattern. How many water quality pattern occur in the study area, okay, in the Kuantan River Basin. Okay, this is the laboratory analysis. In this study, we consider 11 water quality parameters, okay, which is namely dissolved oxygen, pH, salinity, electrical conductivity, total dissolved solid molecular nitrogen, nitrate, turbidity, molecular oxygen demand, chemical oxygen demand, total suspended solids. Okay, this is this case study. We consider 36 primary data from the field sampling and the laboratory analysis, and it combined with the 2,700 secondary data from the previous 15 years of monitoring program in the Kuantan River Basin. Okay, the data metric used in this study is 11 parameters times 2,736 rows. Okay, observation from our study. Okay, in this study we apply 4 chemometric techniques, namely hierarchical cluster analysis, okay, to determine the spatial classification of water quality pattern along the river basin. And the second one is discrimination. So we try to discriminate, okay, based on the 11 dependent water quality parameter. Sorry, based on the 11 independent water quality parameter, we try to determine which parameter spatially shows significant changes in its concentration from upstream to downstream. Okay, so significant changes spatially. And the third method is principal common analysis to identify the most possible source of variation in contributing pollution in the river. Okay, and the third one, we apply the artificial neural network to estimate the percent contribution for each possible source of pollution given by the principal component analysis. Okay, actually in this method, in this chemometric techniques, it involves both supervised and unsupervised pattern recognition technique. Okay, this is the basic concept. Okay, the basic concept of the chemistry. Okay, I think all of you are familiar with this descriptive statistic. Very basic. Okay, this is the variance. Okay, variance. Okay, from the water quality samples. Okay, if the point sampling located at the upstream and the area surrounding the upstream of the river basin dominated by river, meaning that, okay, at that particular area, less point source of pollution, or we can consider as clean water. The water quality fall under the clean water category. Okay, we can see from the line graph. Okay, the green one. Okay, the dark green one. Okay, this is the less variant compared to the second one. Okay, the light green color lines. Okay, which is the sample we call most possible. The most possible area we collect the sample is in the middle stream of the river basin. Okay, so upstream river basin, less polluted area, and the second river basin and the middle stream of the river basin, the point source operation may increase. Okay, and maybe the small village, okay, small industry or district town located at the downstream of the river basin and it will introduce the more point source of pollution. So the variation is quite high compared to the upstream river basin, and the downstream of river basin, industrial area, big city located in the downstream of the river basin, okay, which is the in this case study, Kuantan City Center, Kuantan City Center located here, and also the big industrial area also located in the downstream of the Kuantan River Basin, and the variation is quite high relatively compared to the sample taken from the middle stream and the upstream of the river basin. Okay, that's why LPS is low pollution source of pollution. But the middle stream, the variant is smaller compared to the downstream variant. HPS refer to the high pollution source of pollution. Okay, this is the cluster analysis. The basic theory. Okay, we need to understand is usually the cluster analysis, the result by the dendrogram. Okay, I show you in this figure. Okay, this is the blue color one. Okay, cluster 1, cluster 2, yellow, and the red one is cluster 3. Okay, the cluster 1, if we refer to the variants A and B, members from the same group shows similar characteristic, or if we do the statistical test from these two samples, okay, it will shows the statistically no significant difference between A and B, which is it's similar to each other. And cluster 2's C and D also similar to each other, and E and F also similar to each other. But the members from group 1, cluster 1, okay, if we compare to the members from the cluster C, for example, A and C, in most probability we can get the result is it shows statistically significant difference. Okay, and that's why this dendrogram members in the same cluster show similarity to each other. Okay, this is the discriminant analysis. Discriminant analysis we applied in order to determine the most significant parameters. Okay, in this case study, we consider 11 numbers of water quality parameter. Is it possible we reduce the number of parameter from 11 maybe to less numbers of parameter? Okay, so
excuse me, Dr. Juair, we still have 2 or 3 minutes.
Okay, so this is the principal component analysis we applied to determine the source of apportionment of the source of pollution. Okay, and we also apply the artificial neural network to estimate the percent contribution for each possible source of pollution. And this is the application and for the cluster analysis and the discriminant, which the result given by cluster analysis. Okay, then we consider as a dependent parameter in discriminant analysis to do the spatial discrimination of the river water. And this is the application of principal component coupled with the artificial neural network, okay, to predict the pollution level and percent contribution. Okay. Okay, this is the result from the cluster analysis. It shows significant three different water quality pattern occur in the Kuantan River Basin, which is clean, slightly polluted, and polluted, which is clean water come from station number 1, 2, and 3, and slightly polluted from 4 to 8, and the polluted river water come from 9 to 11 point sampling point. And so from the result, we can reduce the number of sampling point from 12 to 3. Okay, this is the map shows the spatial different water quality pattern. Okay, this is the discriminant analysis. Okay, the result shows the 100% correct classification, and we clearly shows that agreed. This result is agreed with the cluster analysis, where the cluster analysis give 3 different cluster, and the DA discriminant analysis confirm yes, the cluster is correct, and then we can reduce the number of parameter using the discriminant analysis from 12 to the most significant water quality parameter. Okay, so we can consider this is the result from discriminant analysis. So we can consider 6 out of 5 water quality parameter for further study for the future sampling point. Then we can reduce the cost of the sampling program. Okay, this is a result from the principal component analysis. Okay, then we can show based on the combination of the strong factor loading here. So we can rename the possible source of pollution. Okay, with the we can rename to the we can rename as domestic and industrial wastewater and surface runoff. Okay, based on the combination of strong loading factor. And the next, using the artificial neural network, then we can estimate, okay, the percentage contribution for both domestic and industrial wastewater and surface runoff. Okay, so it gives us 15% for surface runoff, and the main source of pollution is come from domestic and industrial discharge. Okay, 85%. And this is the conclusion. Okay, so the baseline study and database contour river, the developed by its category of the clean, slightly polluted, and by the cluster analysis. So the number of point sampling we can consider, okay, from 12 to 3 point sampling, and the spatial water quality pattern with the quantum revision was clustered. Yeah, and the 100% correct classification rate into the spatial water quality pattern according to the homogeneity of physical-chemical property by discriminant analysis. Okay, then number 3, the significant spatialization of water quality parameters. Okay, the water quality parameters show significant changes in this concentration along the river was determined by DA, which is pH, stability, and micronitrogen, nitrate salinity, and optical conductivity. The number of water quality parameters could reduce from 11 to 6, and the most possible variation, the most possible source of pollution contributed to the Kuantan river basin is come from domestic and industrial discharge, 85%, and from surface runoff 15%. And the last one, the source apportionment of the possible. So domestic industrial discharge, okay, the main culprit in the Kuantan river basin. Thank you, they all.
Thank you, Dr. Juair. It's very interesting and comprehensive lecture from Dr. Professor Juair, especially in chemometric, in environmental chemometric role in environmental forensic, especially in water pollution perspectives. To us who is not familiar with the chemometric is the branch of analytical chemistry. Is application of statistical analytics, big data, and data mining, and also artificial intelligence to solve the problem in chemistry. Dr. Juair presents a lot of his study findings in Kuantan River, especially for the water pollution. So how the chemometrics can solve the problems in revealing the environmental issues, especially in water pollutions. This is in order to reduce the water treatment costs, to minimize the environmental problems, especially caused by the industrial and domestic waste. thank you, Dr. Professor Juhair, and we hope you remain in the screen because we will have a discussion at the end of the session. Ladies and gentlemen, now we will follow the second presentation because due of the time difference between Jakarta and Mount Pleasant, Michigan, is about 13 hours, and now it just past midnight in Michigan. But Dr. Wasim Haider from Central Michigan University has provided the recorded lecturer. Professor Dr. Wasim Haider will talk about the recent trends of nanotechnology for Society 5.0. We hope at the discussion session, Dr. Wasim Haider can join us. Now, let's we quick look Dr. Wasim Haider curriculum vitae. Dr. Wasim Haider is an associate professor at the School of Engineering and Technology in Central Michigan University, USA. He took his PhD in mechanical engineering at Florida International University in 2010. And previously, he completed his master's degree in materials engineering at Tampere University of Technology, Finland in 2006. And completed his bachelor's degree at Middle East Technical University in Turkey in 2003. Some of his research interests are additive manufacturing, titanium oxide nanoparticles or nanotubes, thin films, graphene-based nanocomposites, piezoelectric materials, biomaterials, surface engineering of photocatalysis, and electrochemistry. Let's now we follow the lecture from Dr. Wasim Haider. IT team, ready to broadcast the lecture.
Hello and welcome. My name is Wasim Haider, and I'm a tenured associate professor in the School of Engineering and Technology at Central Michigan University. First of all, I would like to thank all the committee members for working so hard and organizing this conference. And my special thanks goes to my colleague and a very good friend of mine, Professor Dr. Khalis Abdurrahim, for inviting me to this conference. So thank you. So today, the topic of my presentation is recent trends in additive manufacturing. So before I start my presentation, I would like to give you a brief overview about Central Michigan University. So Central Michigan University, as the name states, is present in the state of Michigan, which is right here. And a little star is representing a city of Mount Pleasant, where the Central Michigan University is located. Although there are no mountains, but it's a very pleasant city. So the Central Michigan University has 7 different colleges listed on the left side. And then it offers, these colleges offers a wide variety of programs, from sociology to biology, to engineering and computer science, medicine. We do have English literature. We do have a neuroscience. We have over 200 undergraduate and 70 graduate programs. And also, finally, we have a beautiful park-like campus, and we are lucky to have all the 4 seasons in the city of Mount Pleasant. Our spring and summers are beautiful. Our winters are also beautiful, but we do get tons and tons of snow. So it's a very pretty and a beautiful and a very walkable campus. So let's start my talk with a basic information about additive manufacturing. So 3D printing is also known as additive manufacturing, is a process of joining materials to make object from 3D models, usually layer upon layer. So a true juxtaposition is that we are adding material bit by bit in contrast to removing bit by bit, especially as you know that in the case of subtractive manufacturing, we remove bit by bit, right, to form a final product. So on the right side, you see a schematic diagram or a flow chart depicting the process of additive manufacturing. The very first step is to create a 3D model in any CAD software. Once the model is generated, then the command is given to the 3D printer, and also the raw material is fed into the printer. Again, with the source of heat, with the selective melting or sintering process at the right parameters, we create a thin layer of a powder. And again, basically the source heat is applied, and then this process continues. Finally, we do get either a fully finished or a semi-finished product. In this slide, it explains the general functioning principle of laser sintering or laser melting. As you could see on the diagram here, that that application of a layer of a powder material. So first, very thin layer is created, and then laser basically selectively either melt or sinter that powder. And once that is done, a building platform is slightly lowered, and then the next layer of powder is applied. And again, the laser beam comes, it basically fuses or melts the powder, and then again, the building platform is lowered, and then the process is continued to get the completed product. So additive manufacturing is in fact a game changer in today's manufacturing industry because of a few main reasons. And one of the most important reasons is because additive manufacturing has an ability to form highly complex geometric features almost without exception. Obviously, it is very demand-based and a customized manufacturing, and obviously it's economically viable. So in this graph, I have complexity on x-axis, and I have a cost on y-axis, and then I have two lines basically, one representing the conventional method, another representing the 3D printing. So now you could see that as the complexity increases, the cost for the conventional methods or conventional manufacturing methods increases exponentially. However, in the 3D printing, it's kind of a pretty steady, and the cost is not very much, even if the complexity is very high. So again, additive manufacturing is a disruptive technologies because it gives you a design freedom. You can pretty much build whatever you can think about it, right? It gives you a lot of flexibility in terms of manufacturing, and also it enables you to make complex geometries, and also you can really customize the product whatever you want. And once again, it's very economically viable process. So again, if we talk about the major fields of applications in additive manufacturing, almost in all the fields nowadays, additive manufacturing is commonly used, such as aerospace engineering, in automotives, in biomedical, and also in tool and mold making. So according to ASTM, there are 7 classes of additive manufacturing. The first one is vat polymerization, directed energy deposition, binder jetting, material jetting, powder bed fusion, sheet lamination, and material extrusion. I am specifically interested in 2 main processes. The first one is directed energy deposition, and the second one is powder bed fusion. So again, when we talk about specifically the classes, mainly for the metals, I would say that we have 3 main classes. The first one is the laser beam melting, and the second one is the laser melting deposition, and the third one is electron beam melting. So in the first 2 processes, laser beam is used as a heating source, while in the third process, electron beam is used as a heating source. Again, as far as the powder bed fusions are concerned, these are some of the very commonly used printers. So you could see the printers by a 3D systems, also by SLM solutions. I've worked closely with SLM solutions. Similarly, we have a Scandinavian company, EOS. Then we have a concept laser printers, and we do have a Renishaw printers. I've been working with Renishaw from past about 5 years or so. I do have their system in my lab as well, and they make pretty cool systems. UK is, by the way, Renishaw is, by the way, a UK-based company. And then we do have SLM 250 by Realizer. So some of these are some of the commonly or commercially used powder bed fusion systems. So one of the most important thing while working with additive manufacturing is the processing parameters. So I have listed few very important processing parameters which one should know when you're doing the 3D printing. The first thing is laser power. Laser power is basically the energy used to melt powder. Secondly, we have the wavelength of that laser source. Another important point is layer thickness. That's the thickness of the process layer. Then we have a scan rate, the speed of the laser movement, how fast your laser is moving. Then we have a spot size, how focused your laser beam is. That's the diameter of the laser beam. Then we have a scanning patterns. It's a scanning strategy used to process layers. So right in the bottom of this slide, you could see the 3 different scanning patterns. There's much more than 3 different, there are many patterns, but I'm only representing here 3 patterns. And you could see there's a chessboard pattern, which is quite cool. And then we have a hatch distance. That's also a very important processing parameter because it gives you a distance between the 2 consecutive layers. And then finally, we have the energy density, which is basically energy per unit volume for additive manufacturing. So some of these processing parameters, needs to be considered when you are printing your part. I'm going to briefly talk about the effect of laser power. So I have the 2 diagrams here. Once you have a high laser power, you could see that the melt pool is much bigger. So once the melt pool is much bigger, which means that it will have a very low cooling rate or very slow cooling rate. Similarly, when you have a low laser power, which means that the melt pool is going to be a small, but that also means that we will have a very high cooling rate. So every time when you choose the laser power, you need to look into, whether you need a very slow cooling rate or a high cooling rate, so on and so forth. Once you have the laser power, you select, if you have a slow cooling rate, you could see that you will get a large size grains. And if you have a high cooling rate, you would get a small size grain. As you know, most of you guys know that, the microstructure will ultimately determine the properties of your material, right? So depending on what type of the microstructure you want, so you have to choose laser power in that manner to see if you need a slow cooling rate or a high cooling rate. So you can choose the laser power accordingly. And finally, a little bit in the introduction is that additive manufacturing is also a serial production process, and it is now substituting the conventional manufacturing routes. And it can produce, pretty much all types of, materials, including ceramics, composites, metals, and polymers. And also it can make solid, cellular, or even porous materials, as you could see in the upper example. And in the recent advancements, it is basically we are able to make pretty much all sorts of materials of all of different types. And by the way, this picture is representing Renishaw AM250 system, which we have in our lab. And very quickly about the microstructures of additively manufactured alloys. So I have choose 3 different examples here. The first one is aluminum, silicon, magnesium, and the second one is cobalt, chrome, molybdenum, and the third one is 316L stainless steel. So you could see that, for example, when you focus on cobalt, chrome, molybdenum, you could see that the higher melting point of solutes like chromium or molybdenum result in the formation of grain boundaries. And the immiscible solutes like molybdenum in cobalt chrome is solidified at grain boundaries, mainly at grain boundaries. So, and so on and so forth. So also now, as I said, microstructure is really determines the mechanical properties of the materials. So it also depends on, all of these mechanical properties also depend on the build direction. So I have three different types of builds. So I have labeled here A series, B series, and C series. So depending on how you build, so this is a regular dog bone shaped tensile testing specimen, and you could see in the little table below that you can get a very high ultimate tensile strength in the A series as compared to B and C series. Similarly, the Young's modulus is very high for C series as compared to A and B series. And so on and so forth. So which basically tells you that your properties, your mechanical properties are also going to vary depending on your build direction. So now a little bit about my research here is that there is a scarcity of literature when we talk about the electrochemical properties of the materials. So what we are doing is we are studying the electrochemical response of additively manufactured alloys and its difference with the conventional or a rod counterparts, under different simulated conditions. So in today's presentation, I will be mainly talking on stainless steel and titanium alloys. So here we have two types of materials, stainless steel and titanium, additively manufactured, and then as a control sample, we have a wrought stainless steel and a wrought Ti-64. So after we made our samples with additive manufacturing or the ones which we got as a wrought materials, we simply, grinded them, cleaned them ultrasonically, and finally we water rinse them before we start any experiments. So now let's talk one by one. Let's talk with 316L stainless steel. So first thing we do is we quickly perform the EDS analysis to see if the compositions are, if the wrought and additively manufactured are same or not. So you could see in the table on the left that additively manufactured and the wrought are pretty much same in the composition. Similarly, when you look at the XRD graph, you could also see that the XRD patterns are pretty much same for both of the stainless steel. But now when we look at the microstructure, you could see a fairly large size grains in the wrought. However, when you look at the additively manufactured sample, you could see a very small cellular types of structures. And then you could also see some directional solidification or more like a columnar type of structure. You do see a melt pool boundaries, and then we do have some remelting regions. However, in some of the regions which I focused as an inset, clearly depicts that there is a cellular pattern was observed during the additively manufacturing. So in other words, the microstructure between the wrought and additively manufactured is completely different. So now moving on to experimental procedures on these two types of samples, we have performed the detailed, XPS analysis, which is X-ray photoelectron spectroscopy. Then we have done a detailed electrochemical characterization, such as electrochemical impedance and cyclic polarization. By the way, we have used three different types of mediums or simulated fluids. The first one is a blood serum, that's a real blood serum, and then we have a simulated phosphate buffer saline and also 0.9 molar NaCl. And as far as the biocompatibility studies were concerned, we have used a pre-osteoblast MC3T3 cell line, and we have taken pictures of these cells on the top of these two different types of manufactured 316L stainless steel after 24 and 48 hours. And then we highlighted them, the nuclei and the cytoplasm using NUC blue and actin red. So let's move on to the XPS analysis. So again, it basically tells you the detailed surface chemistry, including if the metals are in the elemental stage or if they are in the oxide forms and so on and so forth. So when we look at the additively manufactured and the wrought oxygen, chromium, and iron high resolution spectras, they are pretty much the same, except that sometimes we do see a little bit of extra oxide formation on additively manufactured samples. Similarly, when we look at electrochemical impedance spectroscopy, you can clearly see that when you use whatever the medium is, whether it's a blood serum or the PBS or the 0.9 molar NaCl, you could see that semicircle for additively manufactured is bigger than that of the wrought, which basically tells you that it is much more corrosion resistance in these mediums as when you compared it with a wrought. So similarly, when you look at the charge transfer resistance obtained from these graphs, is that you could see that the charge transfer resistance in serum, in PBS, and also in 9 molar NaCl is higher for additively manufactured as compared to wrought counterparts. Similarly, when we look at the cyclic polarization curves, that clearly depicts that if you look at the breakdown potentials, by the way, all the 3 blue curves are for wrought and all the 3 red curves are for additively manufactured samples. And now when these little circles are representing the breakdown potentials, so the breakdown potential for additively manufactured samples in all the 3 mediums is much, much higher as compared to the wrought counterparts. And again, in this histogram is showing the exactly same thing. So finally, as far as the cell proliferation experiments are concerned, again, these are MC3T3 cell line, pre-osteoblast cell lines. So you could see that that the cells are more proliferating. So when you compare first with 24 to 48 hours, you could clearly see that the cells are proliferating and they seem happy in a sense that they are, their lamellipedia or folopedias are kind of expanding. And at the same time, if you compare the wrought and the additively manufactured, you could see that maybe the wrought is kind of behaving a little bit better in the first 24 hours, but after 48 hours, you could clearly see that additively manufactured, the cells are much more proliferating for additively manufactured samples. And similarly, on the right, you could see the Western blots we have run for 3 different types. We have osteocalcin, and we have RunX2, and cleavage caspase. So here in each one of them, or at least the first 2 types, you could see that that additively manufactured is slightly behaving better. However, the wrought is a little bit better for the cleavage caspase 3. So now just to give a conclusion regarding this first project is that the similar chemistry of the passive film was observed for AM and for the wrought 316 stainless steel. And similarly, we have a higher resistance to localized corrosion for additively manufactured as compared to the wrought counterparts in all 3 biological mediums. Similarly, higher cell proliferation, especially after 48 hours, is observed when compared with wrought 316L stainless steel. Now, quickly jumping on to the second project, which is mainly for the dental applications. So we have selected titanium, aluminum, vanadium, and we have printed this one using AM250 Renishaw printer. We have used the laser power of 200 watts, and obviously using the argon atmosphere, we have a hatch distance of 105 microns and a layer thickness of 30 micron. And in this diagram, it kind of tells you that here is that implant, and we have used a potentiostat to run, cyclic potentiodynamic and also the electrochemical impedance, experiments. So before I jump into the results, I quickly want to show you that that using the EDS, we have found the compositions of SLM, or selectively laser melted, and the wrought. They are pretty much the same. And we have used the artificial saliva. And here's a composition of the artificial saliva shown in the upper table on the right. And this artificial saliva has different types of compounds, as you can see, and then their mass concentration is given as well. Now, what we have done is we have divided our, we have made all different types of solutions, because what we did is basically we added, let's say, a sodium fluoride into the artificial saliva and make a one type of solution. And then we have added, let's say, calcium chloride into artificial saliva and make it as another type of solution. Then we have a, original or pure artificial saliva. We do have a deionized water, and we do use lactic acid and artificial saliva, and also lactic acid and deionized water to see the effect of different compounds on the electrochemical and the other properties of titanium, aluminum, vanadium. So let's first look at the microstructure analysis. So these are the micrographs we got using the scanning electron microscopy. So you could here clearly see that in the SLM, or selectively laser melted sample, that beta is kind of more elongated. However, the beta in the rod samples are kind of more, not agglomerated, or more agglomerated instead of more like, columnar or longer, right? So this was the basic difference between the microstructural analysis. And then when we did the XRD analysis, we did not find any significant difference, except that we did observe a few extra peaks, mainly at the two planes I would like to mention, 102 and 110 planes. We did see strong peaks at those planes in the SLM sample. And by the way, when we did the EDS analysis, the XRD patterns, we did see a little higher percentages of the volume fraction of alpha prime is a little bit higher for ROT as compared to SLM. So here are the detailed electrochemical impedance spectroscopy data. It's kind of a mix, because what we did was, so you could see, for example, in the A graph, you could see that a semicircle was initially lower, but once you go at a little bit higher frequencies, you could see that the semicircle is getting bigger for the additively manufactured sample as compared to the rod. However, in B and C, you could clearly see that SLM is behaving better in all the frequencies. However, in some other ones, like in D, for example, on the left, you could see that ROT is behaving better. Similarly, when we did the Nyquist plot of SLM and ROT in DI water and DI fluoride and acid, you could see that, for example, in DI lactic acid, additively manufactured sample is behaving better as compared to the ROT. However, when you look at a lone DI solution, again, you observe similar type of behavior where additively manufactured curve is behaving better as compared to the ROT material. This is the equivalent circuit models on the right, which we fitted using the EIS data, and we have drawn 3 different models to depict 3 different oxide film behavior. And also we have run the some other experiments, and we got the corrosion current densities, and corrosion current densities of both of the samples are depicted in that diagram on the left. So finally, to conclude that microstructural examination of selectively laser melted Ti-64 revealed a relatively fine and higher concentration of beta content as compared to the raw Ti-64. And also XRD analysis confirmed that the presence of higher beta phase in SLM Ti-64 as compared to ROT. Again, when we talk about the corrosion resistance, we see that selective laser melted has a higher corrosion resistance as compared to the ROT, especially when the pH is above 6. Also, however, when we studied these corrosion resistance in artificial saliva and lactic acid, rot is behaving, better as compared to SLM, especially when the pH is below 6. And last but not the least, both SLM and rot depicted significantly reduced corrosion resistance in artificial saliva and lactic acid, and also deionized water plus fluoride solutions as compared to all the solutions studied. So with that being said, thank you very much for listening to my presentation. I would be happy to answer any questions. So if you have any questions, please feel free to write me. My email is listed here on the slide. It is haide1w@cmish.edu. Thank you very much.
Okay, thank you, Dr. Asim Haider, for your very, very interesting and complex lecture, especially in recent trends in 3D printings. That is the use of additive manufacturing ability to form highly complex geometric feature. Basically, the lecture of Dr. Haider, how to use the additive manufacturing to substitute conventional manufacturing route. I don't want to make a further conclusion. I believe all of participants has followed the very interesting lecture from Dr. Haider. Due to time constraint, now we jump to the third speaker from Dr. Enik Juliana. Dr. Enik Juliana will talk about the fisheries management for Society 5.0 in Indonesia. Dr. Enik Juliana, SPIMT, is an associate professor at the Coastal and Marine Resources Management at Universitas Terbuka, or we also call Indonesia Open University. She currently serves as coordinator for program evaluation and accreditation at the Office of the Vice Rector for Academic Affairs at Universitas Terbuka. Dr. Juliana completed her undergraduate education at IPB University in Indonesia in the field of fisheries product technology. Then she continued her master's degree at Bandung Institute of Technology, or ITB, in the field of environmental techniques. And her doctoral education completed again at IPB University in the field of coastal and marine resources management. In short course program, she took ecosystem approach for fisheries management in Wageningen University, Netherlands. Her research interests are coastal and marine resources management, fish ecology, marine biodiversity, marine environment, conservation, biodiversity, and marine protected area. Now, please, we follow the Dr. Juliana presentation. Time is yours, Dr. Juliana.
Thank you, Mr. Agung, as a moderator in the seminar today. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon, everybody. Today, I would like to present my article about fisheries management for Society 5.0 in Indonesia. Let me share my PPT, Pak Agung. This is my article, Fisheries Management for Society 5.0 in Indonesia. Okay, so this is my outline presentation. We will discuss about Indonesian fisheries potential and then some issues in Indonesian fisheries management, includes overfishing, data availability, and human resources. And then about Industrial Revolution 4.0 and Society 5.0, and Fisheries Management for Society 5.0, and closing remarks. As a maritime country, Indonesia has 62% of waters area and also has MSY of 62 million tons per year. And Indonesia also has around 1,193 species of fish. All of this, the potential have provide economic benefit and ecosystem services to coastal communities and to all Indonesian community. About the fisheries production in Indonesia, this is a graph. This is comparison between capture fisheries and aquaculture fisheries production in Indonesia. As we can see in the graph, capture fisheries is lower production than aquaculture fisheries. The capture fisheries contributes around 33% from total production fisheries in Indonesia, and aquaculture fisheries contribute around 67%. This is a good condition, I think, because aquaculture fisheries is improving in Indonesia and become dominant fisheries production. This condition also indicates that the aquaculture fisheries are helping capture fisheries significantly to fulfill the fish consumption domestically and internationally. And then we can compare Indonesia fisheries and world fisheries. This graph shows the capture production in aquaculture production in the world. On the contrary, capture fisheries in the world is a higher production than aquaculture fisheries. The capture fisheries contribute around 54% from total production in the world, and aquaculture fisheries contribute around 46%. I guess one of the problem in Indonesia is recording data of capture fisheries. So there is the different condition or different comparison between capture fisheries and aquaculture fisheries in Indonesia and in the world. So this is details of data between capture fisheries and aquaculture fisheries in the world. As we can see, here is increasing fisheries production from 2016 until 2018. Next, we will discuss some issues in fisheries management in Indonesia. The first issue is overfishing. We can see on the slide, there is the increasing production in the world from 2016 until 2018. And majority of top 10 capture of fish species have been overfished. This is also true in Indonesia. Some fish species are also subject to overfishing. For example, from my research, two species from 4 species in Karimun Jawa National Park waters in Central Java have been overfishing. We can see in the slide Caisio kuning from Caisionidae family and one family from Sirenidae family have been overfishing with exploitation rate number more than 0.5. Based on Pauli criteria that sustainable exploitation rate value is less than 0.5. Exploitation rate is calculated from the value of fishing mortality and natural mortality. Sustainable fisheries will be achieved if the fishing mortality value is half of the total mortality. This is the figure of reef fishes in Karimun Jawa National Park. And another example of overfishing from my research also, there is 3 species from 5 species in Wakatobi National Park, Southeast Sulawesi, have been overfishing with exploitation rate number more than 0.5. And then the second issue of fisheries management in Indonesia is data availability. We know fisheries data fundamental part in fisheries management. Why? Because fisheries data is needs for prediction of fish stock in the future, for evaluating of habitat quality, for decision making for fisheries management, and also research and development. The third issue in Indonesia fisheries management is human resources. I explain human resources in fisheries management in Indonesia includes fishermen and stakeholders. Fishermen, the main actor in fisheries activities that have a low level of education, lack of technological skill, and low level of prosperity. And also the stakeholders in fisheries management in Indonesia have lack of technological skill, less awareness towards sustainable fisheries, and lack of knowledge and skill. All right, and next, the Industrial Revolution 4.0 and Society 5.0 also comes to Indonesia, and that's main mission to increase productivity effectively and efficiently. The mission can be achieved through 4 aspects, includes technology development will be centralized at humans' habit, and then transform the big data in all aspects, and working with artificial intelligence, and encourage everyone, includes fishers, to think innovatively and critically. So, Industrial Revolution 4.0 and Society 5.0 can give direct impact to the fishery sector through utilizing digital technology and advanced fisheries data system, and then advanced technologies, artificial intelligence, and advanced machine. Utilize artificial intelligence, digital data storage, drones, robot, and so on. And then supervision on fish catching activities can also be relying on the location point that's informed by the fisher. In general, next challenges for sustainable fisheries in Indonesia we should introduce digital technology to environment, social, and economics domain in fisheries management. Everybody, this is example of utilizing digital technology for fisheries management in Indonesia. There are some innovation about tools, application, and robots. We can see the first example. This is the sea surface drone for monitoring and evaluation coastal ecosystem. And the second example is underwater televisual system for monitoring and evaluation underwater vegetation and coral reef ecosystem. To achieve fisheries management for Society 5.0, we have to prepare human resources through some aspects, education and training for fishers, governments, students, and stakeholders. And then education institution must be involved in communities that can help coastal community to live their life. And in this context, Universitas Terbuka as a higher education has been contributing to prepare human resources by offering some certificate programs that can be taken by fishers to improve their competencies towards digital era of marine and fisheries. And then Universitas Terbuka offer a degree program, includes undergraduate program in Faculty of Science and Technology, includes fishery science in it, and then postgraduate program in master degree about fisheries management study program. For communities, Universitas Terbuka offering massive open and online courses, e-training, and another certificate program. Universitas Terbuka also has Indonesia Cyber Education Institute to increase networking to conduct learning, research, and another activities in digital era. So maybe we have a question, what's the existing contribution of Universitas Terbuka for Society 5.0? Now, Universitas Terbuka has been developing and conducting curriculum that includes data science, big data, and artificial intelligence. And then developing interactive digital learning materials for students, online tutorial, online practicum, and online assessment. In general, Universitas Terbuka is ready to contribute for increasing competencies of human resources in fisheries towards Society 5.0. As a closing statement, I would like to say that any future policies made for marine and fisheries for Society 5.0 should prosper the fishers and the other stakeholders. That's my presentation, and thank you so much for your attention. Back to you, Pak Agung.
Thank you. Dr. Juliana, for your very interesting and insightful lecture, especially about the fisheries management for Society 5.0 in Indonesia. Dr. Juliana basically talked about the production of aquaculture compared to capture fisheries, and where the aquaculture production higher than fisheries capture. And the opposite occurred in the world, where the fisheries production from capturing higher than aquaculture production. And also, Dr. Juliana talked about the issues of human resources in fisheries and how to solve the problem in fisheries to use the technology development under artificial intelligence and also big data, and supervising the fish catching using drone, and also monitoring the underwater activities to protect our coral areas. That is basically Dr. Juliana talked about. And then now, because of the time, we follow the question and answer sessions. Please, the IT team to show the question. The first question is from Fani Widodo from UT to Professor Juahir. To what extent does the application of chemometrics in environmental forensic influence the decision-making by the government in Malaysia to fight against water pollution or environmental issues? And then the second question from Joko Istianto, and also for Professor Juahir. Have you ever measured the qualities of water, especially groundwater, in some Asia countries and found the more specific problems and troubles for keeping quality water in some countries? Professor Juahir, please.
Thank you, Dr.
You
Putra.
can answer the question.
Okay, I answer question number one first. Okay, actually in Malaysia, we are facing a lot of chemical pollution which pollutes surface water. We are developing the environmental forensic procedure in applying chemometrics to make sure we do not lose the court cases, primarily for chemical contamination. Okay, this is the collaborative work between the Department of Environment, Chemistry Department, and Public University Malaysia. Okay, that's all for question number one. And for the question number two, yes, I'm also involved in groundwater quality studies. Okay, in Malaysia, we face problem from the chemicals contamination released by industry, saltwater intrusion, and the natural sources of contamination that's come from soil property. Actually, all the source of contamination come from the man-made pollution, and the enforcement is needed. Okay, to control the pollution source. Thank you.
Okay, next question to Dr. Juliana from Asep Sunandar. I live in the marine coastal. What is the maximum fishing limit for consumptive fish allowed by the government? And the second question is how to educate the fishermen and the surrounding community to care about utilizing natural resources for the benefit, welfare, and sustainability for a marine ecosystem. Dr. Juliana, please, you can answer the question from Asep Sunandar.
Okay, thank you, Pak Agung. Thank you for Pak Asep Sunandar Sumantri from Universitas Terbuka. I will answer the question, what is the maximum fishing limit for consumption fish allowed by the government? Actually, Indonesian government don't conduct the rule for allowable fish catching. So the rule of allowable catching fish don't conduct yet to fishers. Gitu, Pak Agung.
Yes.
And the two question, how to educate the fishermen? I think it is our homework together. How to increase the fishers' awareness about sustainable fisheries. Maybe we can offer to fishers some training, some certificate program from Universitas Terbuka to increase competency of fisher, and hopefully with the increasing the competency, fishers will have the good awareness to sustainable fisheries. Enough, Pak Agung.
Okay, thank you, Dr. Juliana. For the next question, I want to greet Dr. Any question for Dr. Haider? I believe Dr. Haider is still in the bed now because it past 1 o'clock in the morning. If there is no question for Dr. Haider, okay, we continue the question for Dr. Enik. Fishery sector in Indonesia is a sleeping giant. There are abundant potential with less thought development. Due to increasing need of population, fisheries contribute also to food supply, especially in Indonesia. According to you, how to have more sustainable way of fishing, avoid overfishing without forgetting the increasing need of food supply? Please, Dr. Ernik Juliana.
Thank you, Ms. Fenty from Agribusiness Study Program, Universitas Terbuka. How to avoid the overfishing? One of the steps to avoid the overfishing is we have to have the method of monitoring and evaluation of capture fisheries by measure. For example, by measure the long and width of the fish one by one, and also we have to record the data. The data of fish, for example, long and width of fish, it's necessary for monitoring and evaluation to capture fisheries. And the data also can use to prediction of stock of fish in the future with a specific method. And weakness in Indonesia, the recording data is not good. Maybe I think. Enough, Pak Agung.
Okay, thank you, Dr. Juliana. Due to the time constraint, I think now it's the time for closing the session for discussion. And now let's give a big applause to all of our presenters. Ladies and gentlemen, now we will present the certificate of appreciation to the three of our speakers from our Dean of Faculty of Science and Technology.
Okay, thank you, Mr. Agung. Now we will give you for all speakers today, Honorable Professor Dr. Habisah Juhai. We thank you very much for being a guest speaker at our seminar today. We present a certificate for you. Hope it's well received.
Terima kasih, Prof. Thank you.
And then Honorable Professor Dr. Wasim Haider, we express our deepest gratitude by giving you a certificate. Hopefully it will be well received. And then the last, Honorable Dr. Enik Juliana, SPAMT. Thank you for taking part in this seminar. As our appreciation, we present a certificate for you. Thank you.
Thank you, Bu Nurma.
Thank you, Dr. Nurmawati. And for your information, the question for Dr. Hasim Haidir has been sent by the organizing committee to his email. I hope Dr. Wasim Haidir can reply or answer your question through email too. Thank you, Dr. Haidir, for your time to answering the participant questions. Ladies and gentlemen, now we have a photo session. I believe the organizing committee has prepared the photo session, and then we invite Ms. Fenty to lead the next event. Thank you very much for your attention, and see you again in the next seminar.
Thank you very much once again, Professor Zuahir, Professor Haider, and Dr. Enik, and of course, Dr. Putra for a very interesting discussion. Now should we start our photo session led by our IT team. Please, Mr. Mahdi.
Okay, get ready. 3, 2, 1. Second slide. 3, 2, 1. Next. Third slide. 3, 2, 1. And the last slide. 3, 2, 1. Okay, done. Mrs. Fenty.
Okay. Thank you very much, Mr. Mahdi. Distinguished guests, ladies and gentlemen, as we finish our agenda for this afternoon, we will have a break and we will start the parallel presentation session at 1:30 p.m. And the presentation session will be divided into 9 virtual rooms. Please notice the topics. Room number 1, 2, 3, and 4 is for the big data science and information technology topics. Room number 5 and 6 is for food security and health topics. Room number 7 and 8 is for biodiversity and sustainable environment topics. The breakout rooms can be accessed through the breakout room icon below your monitor. Please kindly check our program book to gather information about the topics presented in each virtual room. And lastly, please fill the attendance and feedback form at the chat box. We do hope you enjoy the knowledge sharing session, and until we meet again in this main room for the closing agenda at 4 p.m. Thank you.